Hey, thanks for coming on by, Dee What That? You are indeed first. Hope your Tuesday's been going well. You enjoyed some sequel if you attended that stream earlier today. Yeah, well, I think it started off as a backend as a service. Whoa, dude, like a straight on Firebase alternative replacement. And then when they made it, they were like, well, we need to use a database. And they could have went NoSQL like what Firebase actually uses, or they decided to go SQL. Then they picked Postgres for that, which means they had to have a Postgres database, so they had to make all that accessible in a way that was equivalent to Firebase. So it is a backend as a service. It just also includes a database, just like Firebase is also a backend of service, which also has to include a database, which you could just use independently. Like if you just need some water, then a faucet is good, but a kitchen sink also works, even if you're not going to use the rest of the kitchen sink. Oh, geez. I mean, big data is going to be big data, kind of no matter where you go, though. I mean, yeah, I love to hear the pros and cons that you're feeling out of it already at these stages. Yeah, I think you're probably going to be feeling more SQL versus no SQL pros and cons versus really being Firebase. But hey, I guess you're going to be the first one to test its limits. It is meant to be super user friendly just simply it's meant to be user friendly. There's nothing more to really say about it. I mean, Firebase itself is also on this degree of user friendliness, so like it's matching its competition there. It's just they're using a slightly different database schema. But yeah, Advent of Code Day 21 is here. Advent of Code 25 challenges released over December. We're solving the next one right now. Lots of letters, lots of things. We got some math. Oh, I think I can understand what this is. Well, I think I can see this. Hopefully, I'm cool enough to see this, but I think it's just variables and the monkeys, them darn monkeys again, doing math. Can I not see this? A root. Oh, root's a special one. Okay, let's try and read this. What the monkey named root will yell before the monkey figures out itself. So I have to do lookups for these ones, which is this one and this one. Wanes. Okay, so there's a waning thing. It's one of its numbers. By firing 30, Well, after finding 30 multiplied 5, 150. Till root numbers are 152. Okay, I guess my first example is 152. 30. And already has the other number. This allows it to tell its own number. Finding 30 multiplied by 5. This one. Root yields a number. Okay, it's just showing things. What number will the monkey named Root yell? Oh, I think I can do this. Okay, so this is going to be const register equals. Yeah, it's going to be like that. It's going to be for const line of data dot split by the new lines. Const key equals line dot split. Const value equals. That's not how we're doing it. We're splitting on the colon. Then this is the rest of it. After that, now this is where we're going to start figuring the fun stuff out. If we're dealing with letters, so I guess we got to do some matching here. If we see letters, then we look that up in the register, or we put that in the registry, right? If it is not is a number value, then we just put it in the thing. Register dot set key % is not assignable. Darn you. There we go. Ah, CockroachDB. I've heard some stuff about that, never given it a try myself. Okay, we'll look at what operations we have. It's always a number or it's two other things, right? Okay, we can do that. Const left. Oh, there it is. Const A, B, op. I guess we're splitting on spaces. That's not exactly what we're doing. We are splitting on other stuff. We are splitting on plus, minus, subtract, divide, and in that order, which I just said them. Completely accurate. We're keeping these, so in a group, get in there. And then we're gonna, if reg store has, okay, we obviously doesn't have all that. Yeah, I mean, I felt the same little moving, needle movingness when I put a lot of data in a MongoDB too. Yeah, right, I get that 500 megabytes. You do a lot in 500 megabytes. Register dot put set key. Oh, this is correct. Q. Const. I guess this will be const. No, we can't make a dependency thing. That's gonna be bad. We're just gonna put number or object a string op. It's gonna be one of these things, but you're a string b string. So if you can't do that, we will be doing this later, but not now. Congratulations, you go in there. And then it's gonna be while not root while true if let's get the root one. Const root equals register get root if, well, let's try to figure this out. Basically we want to keep trying, so we want to do the substitution, right? So we kind of want a queue of dependent things. So const q equals a lovely array. And root is being the first one in the queue. Got it. So while q dot length, then we're going to say const next equals q. No, we're not doing that. Okay, I'll rename this as a stack for Copilot's purposes. We're going to pop something off the stack, and then, although we're not popping something off the stack, we're looking at it. We don't pop something off until it's fully computed. So just take a quick look, give me a quick gander at it. If const a, come on, a equals, no, that's not what you are. Well, first, you're never undefined, so let's put a return there, so get clock off our back. If type of next, oh, I have to get value. Const value If type of is number, then congratulations, you're good. Stack pop. Here's the fun part. If blah, next triple equals root, return value. Boom. Otherwise, move on with your life. There we go. So cost A, B in operation. If A and B are number, good. Then, yeah, we're going to update the registrar. Set it to the evaluation of those. Perfect. Otherwise, and then delete A, delete B. Excuse you, we're not doing what the heck that is. If A is not, okay, we can do this manually. So we're pushing B, you're the one we're waiting for. Then we're pushing A, you're the one we're waiting for. If both are not numbers, technically, okay, that's an explicit way of doing all this. Okay, let's clean some of this up. Copilot got a little crazy here. Okay, so basically, if B is not a number, then push her there. If A is not a number, push her there. There we go. Easy peasy. Now this is going to continue until all the things get filled out. Suppose if it's a number, we're already popping and then ignoring. So TypeScript just got confused here. Yes, ignore that. All the way until the end. Undefined not equal 152. Unfortunate. So this is not populating down as we expect it. We can look at the next root. Okay, so we go to root. We don't hit this branch. We hit these two branches, and we return. Whoops. Cannot destructure this of this. Okay, let's look at value before you explode. A is 5, op is undefined, B is undefined. Okay, let's look at the register before you explode. Oh, I can already see a problem there. The numbers got turned into interesting. Registry set key. Ooh, I didn't do an else. There we go. There we go. Don't want to get all confused in layer. Okay, some are numbers, some are just alive. Okay. Property A does not exist on this type. Let's get a oh, actually, that's a TypeScript complaint. Good, big number. Shove it in the fang. Nice. Due to some kind, you should misunderstand. You got the wrong job for the root monkey. You got the wrong operation. The correct operation should be equals, which means it still listens. It checks if they match. Wrong monkeys for this one. I'm a human. Oh no. Which number I need to yell so that root's equality check passes? The number that appears is your input is now irrelevant. Ooh, interesting. Interesting. I gotta solve the equation. Huh. It's gonna be a tough one, folks, because it's math, our arch nemesis. Let's give her a shot. Do-do-do. My lovely input. Oop, drop it in there. Decrement. What is my answer? 301. Lovely. This is an equality check, which we can easily mutate manually. What syntax have I destroyed? What have I done? Tell me what I've done. Oops, I just pasted it without deleting. Easy fix. Okay, so I guess the first one, and the first one is root. Yes. Big scroll. No, first one is not root. Okay, so once I find the root, I will manually rip it out. Okay, so ba-da-da-da-da-da-do. Here comes the fun part. If key triple equals root, op equals chow, and we'll make you let so we can easily manipulate this. And there we go. I'm supposed to return a type of value not equal object, because we're cool with booleans now. And then you're freaking out because of a weird evaluation. What are you freaking out about? What's your problem? Ooh, okay. Well, you're not doing triple. You're doing triple equals because you're cool. There you go. Awesome. So now I need to spit out the right number to output. Let's look where in my small equation human HUMN is used. Right there. Okay, and I am there. So would it be too bad to just let's see what human is in this input. 2. Now. Okay, so what I need to do is output 0, and here's the thing, it goes through a bunch of other numbers. Like it goes through what's human go through here? Human goes through subtraction with JJ, then where's JJ go through? A division of something else. So yeah, what I'm gonna do is I'm gonna try this for a bunch of different numbers and find the one that spits out the equality of true. Okay, so let's build our register, clean some of these up since this is, well, what is this doing? Returning 152. Not what we wanted. But okay, let's start cleaning this up and prepare it to be loopified. Log value, right? So, hope you don't like that. Nope, not a fan. Dang it, I'm touching the wrong one. I've made that mistake before. Okay, false equals not 301. Okay, now what is subject value is not equal object is root, and this is where we gotta do our magic. Console log value false. Now, what was your old value? It got replaced with whatever that was. Okay, so I just needed to check, hey, if next triple equals root. Tell me who you are. I guess you're not value. I mean, you are value. There you go. Tell me, why you? A and then B. There you go. So obviously not doing the trick. Yeah, basically I need to return which number for human makes this one true. And human is always a number. So for let HUMN equals negative 3000. Human, yeah, we're going 3000. This is my range. We need to make a copy of the registrar and pass that to this effectively. Yeah, and these are all console logs. I mean, it's only 3000, but we don't need 3000. So I guess we'll make this into a cute little function. Do the thing. It's gonna do the thing. Boop, you go in there, then you return value. Exactly. Now what you're gonna take as an argument is the register, which is a lovely map. This map right here. Boop, there we go. Big map. Here comes the fun part where we have to make cost. New register is like this. Now, does that work? So I destructure them. I never change these values, so that's valid in my book. There we go. So we have new register, set human to human. Result, if result, return human, what human spat out. Okay, human not defined. Great sadness. Oh, there we go. It's running. Would it be too painful to just put a console log on this? Boom, it ran. No, clock is doing a thing. Let's get in the code. We love you, Quokka. Console log HUMN. Big number, easy one, part 1. Yama. Hmm. Okay, I know the consoles are a bit much, but they're not that much. It's only through 6,000. This is correct. A new register is the old one. Mutate the one thing, making sure that's all good. Yeah, it's not touching the original one. I mean, even if it was, it'd simply be overriding it. Oh, this one is mutating the register. Okay, I mean, I'm curious. Why? Where actually are you? Quokka. Stop. Also, I could do some cool stuff where I don't like cache all the values that aren't dependent on the human instead of recalculating them the whole time. But I don't know about that. Let's jump in here. Start debugging. Terminal still going undefined. Son of a. That means it's not within the 3000s range because it didn't get outputted. Ooh, okay. So we have to literally. Oh, okay. So we're doing the brute force bad way of this. Let's put a time on this. We're gonna do that. We're gonna do it right. Wait, where's my human value? 3000 to 2. Let's let it rip. Let her rip. Hmm. Okay, it takes a moment. Where are you doing? Okay, VS Code is abandoned us. No. Turn it off. Okay, so I think either figuring out how my value is used or caching all the non-human ones is my optimization. So basically, I need to keep track of which ones are dependent on human, then pre-cache all of them first. Hmm. I guess I can do that. Const, I just make a cute little array. Const, nope. Human dependent, lovely array. How would I calculate this? Basically, if you ever include human or anything that depends on human, you are human dependent. So I'll mark you as human once you. Let's look at the example. Right, so human is human dependent, obviously. This one is human dependent because it has an A or a B that's a human, right? And then, well, you're also human dependent. Yeah, that sucks. So you're human dependent, and then this one is human dependent. Oh wow, there's actually not much human dependence. These chain here, it's not human dependent. Okay. Interesting. So that's the optimization. Dang it, 6,000 wasn't enough. Minute and 30. Going 10,000. This is all assuming my code's actually working here. I mean, well, this is working because we're seeing this output here. Let's actually drop this. 9,000 and we'll return 0. Yeah, could not find a solution. Great message. We love that. Now we'll be able to see it. So 6,000 took a minute and a half. Adding an extra 8. Well, technically it's 12,000. Okay. Won't take too much more longer. But yeah, human dependence is basically if A equals human, congratulations. Well, that's not what we're really pushing. We're pushing strings. And then we're pushing B for sure. Yeah, okay, you can figure that much out. Then we're also pushing if A or B. No, not like this. Or B is human dependent directly. Technically, human dependent is a check. So human goes in here. So if human dependent has a, because we'll make this into a set, be cool, be optimized, be efficient. Human dependent, add B, add here. Okay, we'll just redupe this line. Has B, then go ahead and add A if it has A, or, again, could have been variabilized, but we're too late, or B, then push yourself. You are human dependent. There we go. And this should build up a human dependency chain. Now for this one, we're gonna do a quick return no matter what. Excuse me, and in here, let's move this human dependency outside since this is global in a sense. Console log human dependent. Quokka should be able to come on back, so come on back. Ah, great, and I have goofed that. I have passed it an iterable, which means it has taken each element out. There we go, so all of these are human dependent. Anything that wasn't human dependent, you see it saved and gets cached. Now, make sure we got root in there. Okay, good, I want to make sure all that got in there. So if these are all human dependents, then the opposite of this are the ones not human dependents. These are the ones that get cached. So what I need to do is, what's going to happen for the first thing. Okay, let's see. Const is caching I know how to spell the word cache. Non-human dependent. It's going to be whether the size triple equals 1. Because if it's only 1, it is your job. You are the first one on the base scene. You're going to be doing the caching. Okay, so once you're done with this, and I guess that's going to be, you do your little return. Okay, I guess I'm going to want not only the value, I'm going to want that register back. Well, I have that register. It's in reference. Easy. You don't think. You're dumb. There we go. This is where I'm like, am I caching the human dependence? If so, then bada boop, bada bing, you're going to have all this. Then we're going to say for const key value of new register if key or human, where is it? What's it called? What is this dumb thing that has key, continue. Otherwise, put it in my register. Good. This is only if I'm doing this caching. So let's be like, hey, if I'm caching, get in there, and then do all this. Lovely. And this, we're gonna disable the big one, so we can actually give this a run. Now, I hope this will be test enough if this breaks it. Ooh, I am doing big range. What's my actual range? 300, so make that a little more reasonable. Oh, could not find a solution. Okay, let's disable the caching. This was working before, but we turn the caching back on. Okay, so did I flip this around? If human dependent doesn't have, update the register key value. Nope, could not find a thing. Okay, how have you broken my register? Yeah, root is these two, and all these others get mathed away. I'm actually curious, because I do believe I can visually inspect this one. Yeah, so because I kind of did. What do you consider human dependence? So either I missed one or I got too many. Okay, so let's see what I got. We got, like, I kind of need to see both. Nope, come on. Nope, come on. No, I need a new one. Give new. Give new. Come on. There we go. And then over here, I want you to also open. Great, so I can get that. Scrolly woly. Bingo bango. So you look down there, I'll look up here. Human independence is human, obviously. You got SZSC. First, let's get down to the first one, DVPT. Technically, DVPT isn't a human dependent. Yeah, PTDQ is, so you're in here. You're not. HUMN. Dang it, did I put the wrong... Dang it. HUMN. I goofed. I did bad math. Math. Well, it's not math. That's reading. The reading, it got to me. All these letters, I put in the wrong one. Did I put it right everywhere else? I hope I did. Minus, well, 10,000. Go big, go home. Are you still running back here? Could not find a solution. Great sadness. Okay, well, we have this, and I think this is doing the magic now. Yeah, it's still... So that was already timed, 2.5 minutes. Okay, let's leave it there. I want to see if this is actually helping me at all. So, we're looking to beat 2.5 minutes. It's going to be painful. Hey, good morning, KHPS. Thanks for coming on by. We're over here doing some fun math optimization tomfoolery with numbers. We're making somewhat progress, though it's not fast enough just yet. Hope your Tuesday, Wednesday's been treating you well. But I should have had a cancel here. Human dependent. Yeah, that's always going to be the same. Ah, all these checks. I don't really need all these. Yeah, it's numbers. Basically, like we have, I'll show the example. So, human is a number that we have to provide, and it goes through a bunch of math things, as you see. It goes through math things to get mathed away. Dang it, 0. To eventually go into some other thing here, and we need to manipulate the value of this. Hey, I'm glad to hear it. Love some new opportunities. Oh, great. Look, we turned it down, and we're now under a minute, so we turned the number up. And that's a great way to look about life. Always new opportunities every morning. Yes, that's going to take 2 minutes. Let's turn clock off. More math. I guess at this point, I should actually be looking at the math. So, like, what the heck is this math more? HUMN. So it's subtraction. And then it's a division. And then it's something else. Well, actually, hold on. Look at this logic here. Yeah, look at this logic here. So if this, then this one isn't human dependent. This can be cached. Okay, so hold up. If A is human, yeah, I can do exclusionary of a tree here. Not gonna help it too much, but let's give this a shot. Ooh, there you go. Yeah. TypeScript finishing. I assume you mean, yeah, that's the front end. Yeah. I assume you mean something with TypeScript, like React or Angular or something else on the front end. But yeah, sounds like a great thing to finish. Human. Dang it, this is Copilot getting me again. Him. There we go. Ooh, yep, great pairing. B, if this is human. Okay, you're gonna do all this other stuff. Else, be the boring code you are. And be boring. Yeah, I guess we can catch this. Cost is A, cost is B. Yeah, it doesn't take long. Look at the one of us. That safety, it's a great feeling of TypeScript for sure. If A or is B, or if A is B. Well, here's the thing. If A, I don't know, I think I might be adding too much. Because it's only the one. Yeah, let's just see. One of us cannot find a solution. Darn it. Dag nabbit. Okay, I'm not gonna break this caching before I do this. So let's turn this back on. Set's gonna be setting big. HTML dependent add next, that's for sure. But we're not adding my neighbor. Okay. Let's let her rip. 50,000 to 50,000. Okay, make sure, yeah, it's still on. That's right. Mm-hmm. Yeah, it's kind of like a sequel, you know. It's a little spooky before you know what it actually does. Then, like at least like the safety aspect of SQL, it's like, oh wow, it actually makes you think about your data, forcing you to slow down and be just forcing you to mainly be the one slowing down. HUMN, of course, that's compared to raw Mongo or raw queries. I think I don't need this. Because if you're A or B, then I am human dependent. So in this example, P is human dependent. So yeah, this one's human dependent. It doesn't mean Legoland is human dependent at all. Yeah, I mean, because it's there to protect you. You know, it prevents you from making all those mistakes. So aside from getting it set up, yeah, I would agree with you for sure. It's easier. I mean, that's kind of why they're trying to introduce it into the JavaScript toolchain as optional comment syntax, or which is basically what it already has, but to be JavaScript compatible and throw away. Yeah, to get rid of that tooling barrier, which is honestly like once you actually get past it, it's not a barrier, but it's an initial barrier for beginners for sure. Yeah, this seems faster in my brain. My brain likes this, but you're still going. Eh, let's. Eh, eh. Come on. Where's my terminal? Yeah, for sure. But the great thing about it is that you can always, unlike some languages, you can turn off those those hurdle points and just move on if you laugh. Hmm. It feels like almost, all this math. Oh, I'm starting to think about what solvers I could shove this into. Oh no, it's too much. Okay. Your fruit depends on a value. Can I start replacing the value with the number? I already am. I am replacing the value with a number. I can't start if I'm already am. Let's look at my optimizations. So console log register quaka on. There you go. For an hour, for what is it, 300,000 or something you mentioned last time? That's pretty good. It's pretty good rate in my book. Pretty good. Okay, these are all the ones human dependent. Yeah, the one that has human in it. Now, hold on. DVPT, you're not human dependent, though you have to do a lookup, so you're safe. Yeah, pretty good. Yeah, again, I mean this is optimizing. I'm not sure. Yeah, actually breaking into the math is what I need to do, it feels like, but I don't want to. I don't want to. Hmm. Hmm. So I know Wolfram Alpha can take some algorithms, but what input? Dagnabbit. I'm starting to doubt my actual algorithm solver at this point. Took 4 minutes for you to not find a solution. Yeah. I guess we're still comparing against the other one, but geez Louise. Okay, now Clock is going to be like, that's too much for me to look through. I already have you turned off. Okay, maybe that is a bit too much for you to look through, Quaka. Hmm. I know I'm fighting a math problem here, so when you fight a math problem, you need a math solution. So if I turn it into an actual algorithm, though, or an expression, I'm saying the wrong word. I need to turn it into an expression, and then ask something like Wolfram Alpha. What would the... Okay, let's do it right here. Say goodbye to Quokka. Stop eating my RAM. So, root equals pp in this, which is technically these two values equal triple equals this one, which is these two values. I'm gonna build it out manually, then find a solver I can shove it to. In fact, that works. I will actually solve it myself. So you're 32, congratulations. You are 2, congratulations. Which means you're just 30, congratulations. Yep, I'm reducing. Ooh, should I do that? Okay, let's not reduce. That's going to be harder on my brain. What are you? You are 5, congratulations. What are you? You are 4? Okay. What are you? You are these two. Where does the human get involved? You are 4. Congratulations. You are these two. I see the human coming up. Human rearing its ugly human head. You are 2. And then you are the human. Bada boom. Then you are 3. And then you are X, right? So what is Wolfram Alpha? This is one of the things. This is what it used to do back in the day. Although maybe generating this as an eval and just reducing a lot of these. 32 minus 2, 30. 30 times 5, math. Can I reduce any more? It's all... Okay, so I did manually build that expression pretty well. I don't remember the way to generate these. Figure out X, darn you. What is X? I don't know. It's been so long since I've used Wolfram Alpha. Interpreting. Okay, you're plotting a line. I love that for you. Determine. Maybe we can ask GitHub Cope or not this. We need some kind of expression solver. Oh, I'm using triple equals. Maybe that's confusing it. Solve for X. I'm trying to figure out. Solve. Ooh, 301. Okay, okay. So if I generate, I'm cool enough, basically generate this string of an expression. So I did that pretty well. So I started on the root and I just started replacing these with its value in parentheses, replacing all our letters until we got down to the letter X. I think I can do that. I think it's something I can do. So yeah, part 2. You're not doing that anymore. I mean, you're still going. Where's my output? Where's my output? You finished. Where's my output? You ran. Oh, you ran. I'm confused. You ran for 10 seconds. Right, why'd you give up? Oh. Why'd you take so little time? Because you weren't doing your job. Oh, Lord, the console in here. Find it, eliminate it. Okay, have your fun. So what I need to do is convert to expression. After we do the caching, congratulations. Make a cool function, convert to expression, the register. Don't you abandon me too, Copilot? Okay, Copilot, thank you. Big fan. You abandoned. Where's the type? There it is. Okay, so let expression equals, I guess I'm actually pulling the value out, so register.get root, well, it's kind of going back to the original, ain't it? I'm just shoving it all back on one line. Yeah, it is actually the original lines. Let expression equals empty string. This we gotta pull out root manually. Root equals congratulations, you're real. Expression equals thingy, other thingy. Let's not be shy with our parentheses. These ones don't really need them. But root dot, this is your value. Why are you doing this? Register got root dot A, root dot B, and be cool about it, TypeScript. We're cool here. Now it's gonna be while. It's kind of like the old cache. Very much like the old cache. Okay, yeah, it's the old cache. Surprise, surprise, it's back. Yeah, so expression, hard-coded root. Once we pull it out, we do all the magical stuff, and this is where we start filling in the text. So we have to mutate our expression as we do this, and this, you'll live. You shall live. You finish? You didn't finish. Okay, so expression, root, don't do that anymore. Once you pull it out, you have the value. If it's not an object, then it's a number. So we're going to say expression equals expression dot replace next with value. Well, it's not true. You're always a thing. Value to string. That's correct, but well, if this is a number, it doesn't need to be parenthesized. But if you're not a number, that's where things get funky. In my example, yeah, the non-numbers got parentheses. So you're a non-number. You're a non-believer. So replace this. This is for all of them. Expression dot equals expression dot replace. Ooh, this seems pretty good. But A is not a number. You're an object. So it's replacing you not with A, but with this thing, this thing, this thing. So what is it? A dot A? Okay, what the heck is A? Ooh, type of A value. Oh. Okay, you are being replaced by just A, because it's your identifier. You'll get later replaced by your thing later. Congratulations, B. You're also doing that. But for this one, the actual evaluation, I'm replacing... I don't know if I'm replacing anything here. Because I'm generating the statement. Okay, this would be, what, simplification or reduction or something like that. I don't feel like it. Not feeling it. Okay, so once you're doing that, you're going to want to say convert to expression. That's our lovely register. We want to return this expression at some point. Once you get to the root, I guess. There we go. Oh yeah, and you're still doing a million to a million. Let's fix that to 400. We invite Quacker to the party. Let's see if this looks somewhat human readable. It's false. Big fan. You wouldn't happen to finish running? No, you wouldn't have. Convert to expression. You're returning false. You only have one return statement, and that's of an expression. Expression equals expression replace. What's old expression? Might get a few of these. Expression. Root. Not cool, not cool. So we're only replacing when we get to the end of our thing. We need to do it at the beginning. And we need to replace root with technically this right here, right? Because we're doing down traversal. This is up traversal. No. No. Wait, zero's not 301. That's your problem. You were working before. What did I do to you? 400? You're supposed to be cool. Don't know what I broke there, but we'll figure that out. Clean this up, I guess. I'm glad to hear that's happening now. Oof, I really broke it. Drop the human dependence at all. Okay, just drop it. I said drop it. Of course, I'm dropping it from the wrong freaking thing. Yes, we might as well drop it entirely there. Come on, it's four. It's not that many. I have broken it. Well, I guess we gotta fix this. How have I broken? Okay, now it's working. Jeez Louise. So it was the human dependency that was throwing it off. If human dependency doesn't have this key... Oh, I'm caching literally everything. Understandable. Which means this caching, this level, is missing some things. Right? Nope, it's working. The heck? Okay, my eyes have abandoned me then. Okay, back to the real problem. Once we have root, we're going to replace root with something else. So it's not an object, congratulations. Otherwise, it is an object. So expression equals expression dot replace root with, yeah, that seems accurate. Now here we can cancel a log. What do we call this cool function? Convert to expression. I'm gonna pass that register. No one really cares. What is your deal? You were working just fine. Okay, we're gonna mess you up. You're 301, right? So you're gonna go 300, 302, or 299. There, okay, it's working. Now if we put this in the equation, how dare you explode like this? What are you doing? Who do you think you are? Do we need to do this to the new register? Okay. Makes no sense. But sure, I'm not going to question it. Bunch of falses now. Return expression. Okay, so great. We are getting all of our expressions right here. Root. So you keep looking at root. It makes no sense. Next value. What are we at? What are we looking at here? Root false, root true, root false. The heck? happened to the new register? Oh, because we're using new register. Of course, it's going to be all messed up. Don't know why using this one explodes it. Oh, we have to use a new register. Const new register, which is a copy of the old register. Great, we love this. And then setting human to whatever. Great, big fan. Okay, geez Louise. Drop some of these, drop some of these. See if this at least looks accurate. We just want to run this once. So, 1, 3 hundo. Run it once. Okay, so this is accurate. Just not using any of the cool values. Very uncool of it. Is this accurate? You got plus, multiply, subtract, divide. Plus, multiply, subtract. Okay, it is very accurate. Now let's put some numbers in here for crying out loud. So this is where I do the expressionification. Awesome. And then if it's not a number, do that. Okay, this is where I need to do it. So if they're both numbers, then I need to replace A with register gate A and B with register gate B. I got that. Expression equals expression. Come on. We're not writing back in service here. Expression replace the entire thing with the operation? Maybe. Or not. No, we don't replace next. We replace this string that you just generated. Nope, we don't do that. Do not the parentheses. No, wrong one. Not these parentheses. 5 minus 0. Okay, it's cool on numbers, I guess. Where is human in this equation? Did the expression not do its job? Oh, there's human. Yeah, human minus dvpt. Okay. Okay, now the rest of these are against other things. Oh wow, let's not add all the parentheses in the world. We do want to replace these ones like so. Okay, that's happening. And then we want to drop these extra parentheses. Hey, Ryan, thanks for coming on by. Appreciate the alert for sure. Hope your Wednesday's been treating you well. Okay, now we need these words to get out of here. Extension, replace. B, what is... Who is B? Your words, right. So LGVD and PTDQ. You're not in the equation. Uh-oh. I mean, that's good, but I should recognize you. CZ. Uh-oh. Okay, what if you didn't do this? Okay, you are having how are you making an impact but not making an impact at the same time? All good, all good. It happens. I mean, these last two streams I monitor has been like toodles, so I know the feeling. A, B. So where does B not show up? Let's show the new expression. We're over here generating some mathematical expression, so we could hopefully pass it off to some overqualified solving machine. Replace it with itself in parentheses. Well, this is doing literally nothing. You're just adding parentheses wherever you go. It's literally just adding parentheses around the thing. I mean, we will need the parentheses eventually, but this is practically useless. There we go. Now it looks a little cleaner. Now we do want to replace... Ooh, okay, there was some... we need some of these parentheses. Put them back! Okay, I understand the usage of parentheses. We love them. Big fan. Now, why aren't these other ones getting evaluated? LJGN. At any point, we gotta basically figure out... .log... value.a, you're a left-sider. There you go, LJGN. So you show up in this party, and you're replacing this old string. So if value.a triple equals LJGN, also log the entire expression, why don't you? Let's do it on the before. So you're not doing anything, like, at all. Now, why wouldn't you do that? Let's see what your evaluated value spits out to be. Yeah, so expression and big number. 2 times 2. Right, because we replaced the deepest one, and now it's gone. Oh, geez, yeah, that's what we back up for. It only takes one big data loss for you to really appreciate backups, right, folks? Mm-hmm. That's what, like, yeah, we got like another 100 dev are also dealing with their hard drive migration, trying to shove everything onto Google Drive before it all crashes and burns. So it's going around almost. Okay, so these are happening. Maybe we don't want these to happen. So placing it with the value, which we do want. So we want to replace this with, we want to replace an opening and then a closing and then a regex for all the bottom ones. That's if, I mean, we don't know the expression. We could go for both expressions. Well, real parentheses. This is tough. Thought building this expression would be easier. And TypeScript's just spinning its wheels. No, I'm obviously talking about myself. I didn't name no names, Instinct. I didn't name no names. See, I'm the one with the monitor problem. You gotta get your, who's got what technical problem in line, of course. Okay, so we just need to build this expression out. How badly? How long is this expression manually? The expression's stuff like 3,000. That's a big expression. Yeah, what if we only kept the letters, right? We didn't do numbers. I changed literally nothing. What happened? What happened? Okay, yeah, we just generate the words. Then we replace the words with the numbers that we have. Right. Okay, I can do that. Right. We can do that. Okay, so once we're done here, we're da-da, 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 da-da. Great. So for const key and register. Oh, so we want both of these. Key name v if type of v triple equals number expression equals expression dot place name with v dot to string. Why you angry? Oh, for not for n. Oops, the daisel. Expression, there it is. Do we have, ooh, look at this, we have symbols. Now, here's the fun part. If you're human, you don't get to be a name, you get to be a number. Or you don't get to be a number, you get to be a name. So, key or name triple equals HUMN. You are X, otherwise, you're cool. Look at this cool expression. It'd be a shame if someone shoved it into a expression solver and it just solved automatically. How dare you? You were working before. Maybe too many parentheses. Please, cool Wolfram Alpha thingy, do your job. Dude. No, this was working before. Well, I actually solved the right side pretty well. Oh, maybe I have the too many. It's like, what's a triple equals? That's not math. Boom. Okay, this is our magic. So now we're gonna be like, hey, be hard coded. Return like 301 or whatever. Shut up. then this is going to output my new expression. Oh, my clipboard's about to cry. Wolfram Alpha is also about to cry. We're all about to cry here. You exceeded the maximum... But why? But why? I don't have that many parentheses, Wolfram Alpha. Okay, we need... What do we call this? An expression... Solve expressions. Algebra, calculus, Wolfram Alpha, you failed me. Mathway, they seem cool. I do have an X in here, right? Let's grab this scroll bar and look for it. Okay, there's the X. Maybe this is a long one. Enter the equation you want to solve. Lord. Oh, Lord. I am sorry already. The heck is this? Why is this webpage freezing? Okay, I love you, website. We gotta say goodbye to this one. Oh, we say bye. Math Papa. I don't know who you are. Please be math. Solve math. Why are they italicized? Did I do that? Oop, let's solve my equation step by step. No, I love you. I love you. Cool thing. You're great for teaching. I just want solution, though. Answer equals... You're a freaking fraction. What are you doing? I mean... You're not running anything. 8 point... It's not... No. How bad of a scroll bar do we have? Yeah, it's returning another math problem. Okay, x equals this number over this number. Either I generated my expression badly. Oof. Come on, just suggest a feature. No, I'm not suggesting a feature. X minus 415 divided 2. Oh. I mean, no, that's not how the expression's supposed to look. I've missed parentheses. X minus 3 multiplied by 2 divided by 4. Okay, so no, I'm looking at the wrong X. X minus 415, then divide by 2. Okay, so that is actually correct. My word. It could be either of these. I don't think it's the big one. I'm kind of just guessing at this point, unfortunately. Of course not. Let's find another one. I'm pretty good, confident I'm generating this correctly. Actually, let's put the easy one inside this solver. Why am I trying for the hard one? That's not how you do good old test. My browser just absolutely... Firefox is just like, too much math. I am inclined to agree with it. Website, please. Yeah, please. Please, website, be cool. Be cool. Let's reopen that tab. Shove you in the easy one. Why the heck do y'all format parentheses like tiger marks? Tiger scratches. Like, geez Louise. X equals 301. Okay, we got that. Let's see if this one can handle it. Yeah, I know. Every site is doing it for some reason. It's like, I'm gonna start blaming Firefox if I get any more of these. Uh-oh. Let's say goodbye to that tab. Let's put in the easy one. Come on. Don't you abandon me too, VS Code. Your input has more than one equal sign. I can fix that for you. 301. Okay, so you're cool. Look how cool it gives the output. But then when I give it real, it's like, oh no. Okay, so I did have to remove those equal signs. Maybe that's your... I didn't want to take a screenshot. Maybe now it'll be cool. Well, I tried the bottom number. Let's try the top number. Dang nabbit. Okay, let's try this website. I have to hit the go button. Go math. It just laughed in my face. Cannot solve. I didn't remove the triple equals. Okay, there's got to be JS expression solver. Either my expression is bad. Dang it, where'd the browser go? Or these solvers are failing. These solvers aren't exactly succeeding. Math calc. Parser for basic. No, I don't want. I want a solver. Solve algebraic expressions in JavaScript. Sure. Hey, Mirabik, how's it going? We're over here just fighting, trying to find some solver doohickey thing. Usage right now. Yeah. Oh, do I have to really download stuff? Can't you just figure it out? Can't you be cool? Oh, executing the suggested keyboard shortcut. Great. Yeah, I can open terminals. Wow. That's not what I meant to do. Okay, let's see. Expression. Main objects are available. Great. So. Yeah, this one is still failing. So, goodbye, Wolfram. Get the easy one. Oh, there you go. We wish you the best of luck. Where is it? Expression. Oh, we use one equal sign. Undefined. Well, I love you too. Oh, new expression. Sure. E equals new expression. E, and then how do you solve this? Initialize expressions. How do we solve it? E dot to string. But solve it. Evaluate. There you go. So how do you do this? E. But how do you solve it? X multiplied 2, multiply X, add Y, new fraction. Ooh, dot eval. But I don't know what the, I don't know what one of them is. Can't you figure it out for me? Okay, great. I've generated this thing, but X is like, oh great, 301. Okay, X isn't even doing its job. Ah, this was a bad idea. It does nothing. Yeah, solve the equation. Solve the equation. Solve for X. Ooh, here we go. E dot solve for X. Solve for is not a function. How dare you? Quad is new equation. Solve for is not. No, not you. Okay, so this was an idea. It's not doing what I want. Hmm. Ah, math. Did this thing at least give it a shot? Oh, I have to go fix it first. Drop the triple, and there's a parenthesis line about. Where is it? Okay, maybe there isn't one. Yeah, don't know why this thing looks so horrible. Let's try. Give it its greatest try. We believe in you, Symbolab. We don't believe in you. Equation solver. Maybe... Is there any way I can reduce this? Come on, VS Code. Don't do that. All of these, like, we can't solve any of these without having X figured out. Like, they're all dependent. Like, we got the right side completely solved, so... Can't simplify any further. Calculator soup. You're the next one on the list. Great. Shove math expression in here. We got you. Calculate. Unknown character sequence. Okay, drop some equal signs. Clear a parenthesis. Unknown. Use only numbers. I've used the symbols. Oh, wait. Can you not actually... I've used the symbols. Okay, we'll drop 2 layers off you. Incorrect sequence. Okay, I guess you're not a solver, you just evaluate. Okay, go away. Algebra calculator, you still... Yeah, still not doing anything there. Come on. I think it's still in the clipboard. Come on, it should... Okay, we'll grab it again. Get in there. Get in there. Okay, you're not a fan of clipboards, I see. Very uncool of you, website. You know, Wolfram Alpha has already failed. Solve for X calculator. There we go. Give you a shot. I know this site. They've worked good in the past. Drop the triples. Drop the extra. Do the thing. Solve for, well, yep, lowercase x. Where's the button? Where's the button? Or where's the button? Solve equation. I'm blind. Ooh, cool. Okay. Now, I'll apologize to the website as I pasted this monstrosity in. Apologies, website. Let's drop these, drop those, go back to beginning of string, drop that. Sorry, website. That's a number. Where'd it go? It was there. Dang it. There it is. There's a number. Give number. Thanks. No, stop being weird. Just, I want to steal the number. Do I have it? No, I don't have it. Give math jacks. Get out of my way. Oh, wow. Okay, fine. I will manually type you out. 3582317956029. Heh. Haven't tried this one yet. Yay! Now, how am I supposed to do that in code? That's a great question. Nobody asked it. Nobody asked it. Yeah, it feels about right. Me fiddling around. What a time disparity gap that was, huh? Yeah, this number, let me actually look at it. Wow. Okay, so we got 3 trillion? Lord, how am I supposed to... I mean, obviously there's some math way of doing it, and... Hey, website, how did you figure this out? I'll just borrow your code or something. Because the website obviously figured it out. No, algebra classes coming back to haunt. Okay, so all these websites say goodbye. I mean, this website over here, I might actually be able to use the weird algebra JS if I can just get it to work. But yeah, I mean, this is the solution, apparently. Yeah, let's go ahead and drop some of this off and return, or can make a commit of this. First, I'm curious why this code started breaking. Yeah, 0301. Why did this start breaking? Yeah, how did I break my solver with my conversion? I'm just curious at this point. I am the cat, and curiosity I do have.
cannot find a solution, but this one you shouldn't be failing on.
Where's the music gone? Weird.
Yeah, why is this failing at least? At least I want to get this thing. Oh, numbers. Yeah, you succeed. Okay, great enough. Okay, let's let that go. Yes, we'll uncomment this. Oh, uncomment both of those. Why you fail? It's not that many. You. Okay, I guess there's a little bit of logic, but that does work. Let's go ahead and make this commit. I got no idea what educational visualization I can make for this, considering I barely solved it myself, but it'll go on the list. Probably at the bottom of the list, but on the list nonetheless. Okay, so apparently this is like too many console logs. Let's say goodbye to our friend. But yeah, let's give this a lovely optimization. So I guess the first one is going to be const build registrar. Well, and that should include the caching, but we'll do that first. So const parse generate register from data string, big fan, and then basically all these lines right here. Yeah, and I'm actually pretty okay with the data format I have gone with. Though op can obviously be dropped down to type operation equals one of the four. But we love a good literal type. Bingo bango. And we're going to say as... Wow, being weird there. Thanks, TypeScript. Hey, that is what we're doing right now, Instinct. We are shortening all this lovely code. So watch here. We can even do a quick, easy line split. So instead of doing the split on this and then pulling out 0 and 1, it's chow. Cute little destructuring. Yeah, we're getting there, Instinct. Think that works? Gonna be real awkward if it don't work. I assume it works. We haven't called our code yet, so how would we know? Okay, so this is doing what we want it to do. Let's make this a little better. We want to also return our register. And I could whip this into reduce, but we're not going that unreadable. We got all this code down here to be unreadable with. And this is a bad way of doing this. We want to say const parts equals value dot split by the spaces. Now, this, what will this be? Well, if it's this, then it's going to be a length of 1. Otherwise, it's going to be a length of 1, 2, and 3. So, if parts dot length is 1, then we're doing that. Otherwise, A, B, and op. Beautiful. That ain't that much more readable now. Slightly. Okay, 11 this. This for part 1. Someone's being slow. Who's slow? You're slow. Turn a -1. Stop being slow. Okay, now for this, we can say const register equals parse generate register from the data. And here we have our little, it's not really recursion, but our solver going through all the things, collecting all the things. So as great as this is going to get merged with our other solver. Yes, our new and improved solver, Solver 2.0. And then our expression generator, which technically, I guess technically doesn't need the human, but it does work better on it. And this does need to solve the expression as it goes along. So yeah, it's all side effects of getting to the end. So I guess we'll start with, what are we going to call this? Evaluate registrars. Something like fancy like that. Function. Evaluate register. Lovely. And then it shall. So let's, clean this up a little bit. Also have a variable called the human dependence. So the second argument, human dependence. Now let's not get too embarrassed. At least we're not going to put this bad word on GitHub. No, okay, I do have it. DPD. Wow, my mind thought I typoed that horribly. Apparently not. So all the things that are dependent on the human. And then we're just going to use this cute little thing there. And yeah, now what's wrong? Oh, unknown word. You're not wrong. Dependence. It was wrong. Huh. I'm a great Googler. I read everything I Google, obviously. Put these in here. Boop, boop. There we go. And this can be an else if. Ain't that nice? EEA, beautiful. So if A is human or B is human, then we are dependent on the human. Otherwise, if A or B is human dependent, then we are. This is the same line written twice. Yeah, we just initialize. Well, I'm glad I simplified that. We just initialize it with human, and this will do the magic. Let's not do it there. Yeah, let's do it down here. And we don't. Actually, we do need to do it down there, apparently. Okay, let's see if we can drop this TS ignore. That was easy. Okay, so if both are a number, then we're doing the magic. Otherwise, one of them is not a number, so do this magic. Push their things to the stack to calculate at a later date. So I guess we can say cost a value. Well, we don't need the values. Well, actually, we do need the values. Cost B value. Great. Now, instead of saying this 3 times, we can say A value. Instead of saying this 3 times, we can say B value. And while we could do this by grabbing A type, this is only reducing our duplication by 1. Not worth it in my book. Yeah, it looks good there. So if both a number, congratulations. Otherwise, one of them's not. Push them to the stack accordingly. We're using eval. We can avoid eval since we know what the operation is by saying aha, future us will solve this. Okay, let's evaluate the register. So I think we literally just want the value. Return, evaluate register, new set for the human. Because this one is literally first run through, not even doing thinking thoughts. You know what? We're going to pass an empty thing, just so it doesn't, we don't want it to think too hard. I mean, it's going to be doing these checks, but it's an empty set, so no thinking for you. Oh, wow, we didn't even need to put it in a variable, did we? Part 1, always so easy comparatively. And this is where that ends. At least this part is all gone. Generate register from the data. And our expression conversion. Fun, 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 fun. So, can I tack this on to my evaluation of registrar? That's my idea. And how extra expensive would it be? Yeah, I'm gonna tack it on. So all I do is replacements here, 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 and here. So 4 points basically, with a cute little string following us around. Which means you no longer return a number, you return value, and which is a number, and expression, which is a string. Congratulations on your new upgrade. So if there's our value, technically our value is not always a number, it's whatever is returned. And our expression, which we do not have yet. Well, now we do. I guess value. How is value not a number in this one? I was just doing a not object check. Okay, I guess it can also be a boolean or whatever. That doesn't explode anything. Now it's not undefined, so I don't know who told you that. Type is not. Oh, this is who told you that. Easy. Okay, loving that. Okay, we have to make sure this thing returns dot value. Beautiful. Okay, part 1 all done and dusted. Let's get our expression logic in here. So I'm just gonna be moving it over. Expression is replace. Guess we do need the stringification. Stringification. Then if the human gets replaced with an X. Yeah. Let me think this through. Yeah, the human. I guess that can be an optional conversion. We're not doing that right now. Head on down here. We'll start moving the rest over. We got 2 more. Yep, A's and B's, which is basically just 1 more. Oh no, my one-liners just became 2. There we go. A's to A's and B's to B's. I think the last thing is that X thing. Let's see. Conditional that will either replace human with X or with nothing. I can base that on my caching. So if my thing contains human and current name is human, then I Xify it. Otherwise I don't, which can just be another variable. A mapping of names to variable names. I got it. Easy. I think this is the last piece, honestly. This is only root, right? Where did I put this? Oh, it's straight up in the beginning of the expression, so it's every time. That doesn't sound too expansive. There we go. For name value. And this will be variables, I guess. Human dependence. Variables. We'll just call you a record of string to string. You're cool like that. We don't need to be a fancy map. Okay, this thing's catching on fire. Oh yeah, we're just gonna pull. Oh, it's an or. This is gonna be great. So it's gonna be variables name or lovely. Gotta love it. Cannot. Why are you complaining? Cannot read. Ooh, we never passed the thing. So you'll default to an empty object, of course, and you'll default to an empty set, of course. And you're not defaulting to anything. You need to have stuff. Okay, let's get on down here, which means we can drop the set generation. And great, part 1 Still rocking it. Now let's polish this type of value not equal object is really what I'm asking for. I do want you to put booleans in there for whatever reason. There you go. So if you're not an object, then put yourself. Look at that. TypeScript. Where'd it go? TypeScript's smart. If it's not an object, it has to be a number or a boolean. Let's not do that. Because we're already doing our loop anyway, right? Right. Okay, so now, why is this thing angry? Function lacks ending return, does not include undefined. Right, if you never get to the root. Well, that's awkward because you always get to the root, but I guess value. What do we say? How do we say? Can we say nan, right? And then expression empty string because they satisfy the type. There we go. That's our failure return. So you should never return that way. Okay, time to see if all this did its job. Yeah, I guess here you might as well return man while we're at it, being all complacent. Okay, so up here we have consmin dependence equals new set. Of course, we don't need to type you because we're gonna give you a human. Whoa. Those are the wrong symbols. Appreciate you, Copilot, but no. And our const variables equals human, but you're turning into an X to mark that spot. There we go. Human dependence. Result equals evaluate a register. Passing the register, passing the human dependent, and of course passing our one and only. Okay, we can inline this. You don't need to be a variable. So fix our typo of this again. Bingo bango. If you're caching, do the magic. So this. If result return. Result's always going to be something truthy. We're asking for if result dot value. Right? Catch up, Kaka. No, big fail. Guess we should console log in here, see what is up. Nope, not that thing. We want to look at the result. We did modify the register to make, we didn't modify the root. That's awkward. Yeah, so once you do all your fun stuff, we're going to manually say register.get root dot exclamation, not like that, quote root dot op equals equal sign, which is going to be a valid value because I'm going to put it up here. Congratulations. There we go. And as this is angry, cool thing we can do is you can say as. Oh, we can't really do that. And we can do this. Hey, be quiet. Okay, see if this. Well, not for the real one. Invalid left-hand assignment. Well, someone got angry. Invalid left. Let's track that down. There we go. Register invalid left-hand assignment. I've used an equal sign here. We need to use the triple or double equal sign. Triple. A, of course, distinct. Yeah, it's all. I mean, I don't know if I'm gonna get the math. I'm probably just gonna be like, use a calculator, but yeah, I appreciate you. You gotta get some sleep, of course. Gotta get ready for, it's not Monster Monday or Mash Monday or whatever it is, but Wacky Wednesday, I suppose, or whatever the branding for all the floodgates opening tomorrow will be. There we go. Triple equals.
the JavaScript way. Okay, it's 1,000 to 1,000. It's 2,000 numbers. Don't think about it. There we go. And look at that, it works. And look at that, we got a cool expression to show for it. Now this works. Are there any unnecessary parentheses here? I can see unnecessary parentheses. Can I trim this down? We're gonna find out as I set my thing to 299 and 301. So I'm gonna make sure this still runs fast. Super. It's not super fast. Oh, 302, because the less than. There we go. Okay, now we can trim this down. See if we can not use so many freaking parentheses. So let's see if I can get away with dropping these. See if it ruins the math. Doesn't seem to mess it up. And we'll know when I shove it into this calculator, I suppose. Actually, I can right now because it's only like 3 numbers, so let's bring that out. Bring out the big scary one. Probably should have done this before I did that. Oops, that's not going to be helpful because it never gets in there. And let's give that a look. Good. Come on, Quokka. It's only like, what, 4 calls? 3 of them are cached. So hey, we do see that non-optimized, it does actually work. Though, of course, cool is optimized. Okay, expression solver. Time to meet your... Wow, it looks so much better optimized. Time to meet your match. Shove it in there. Drop the equals only. Let's see if we can figure out the rest. Well, it's trying. Or did it complete? I can't tell. Let's do a refresh. Drop it in there. Solve for x. I do have an x. Well, I can't find it, but I promise it's in here. There's the x. Okay, solve. Nice. Okay. There it is. Okay, so this elimination of parentheses, perfectly safe. Yeah, I think we can't really get rid of any more. Let's try and look for... Yeah, we need those for order of operations. So we can get rid of the last set of parentheses, which is first to last character, easily with a little substring slicing, actually. We want slicing, not substring. So we're going to say skip the first character and skip the last character. While you're at it, go ahead and replace the triple equals. Well, depends on what we're passing this to. We'll replace it with single equals for all the calculators out there in the world. Oh, I gotta save for Quokka. Okay, let's see how this thing actually works. Can solve. Am I messing this up with my theme? Ooh. Okay, we can actually read this. Hold on. Solve equations must contain a comparator, whatever. Exact solutions contains blah, 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 blah. Is true. How to solve an equation step by steps. They're not corresponding to the steps a human would take. No. Ownership of source code. That's cool. That's cool. Okay, yeah, so maybe that'll be a nice optimization. I'll just put it in the comments. Put it in this calculator over here. Can we put in the bad value, though? That is what I'm curious. Although, even the bad value has the right set extremely optimized, which doesn't seem realistic. I'm curious, though.
Why you got parentheses? Whoa, who told you to have all these parentheses? Oh, no, I can see it. Yeah, these are the right ones. These are the good parens. It doesn't like extra solves, apparently. Lovely. 301. Well, Max Technica, what we are doing is I am polishing up my Advent of Code solution for today. It was basically given a bunch of expressions and their values. Like the value of root is adding these two values together. So they have to look up those values, look at those values, and do all this looking up. Figure out what root sum to. But part two was that, oh no, we don't know the value of this one. Put in any old number and make sure that the root expression turns into like true or something. So I tried to figure it out, but then I gave up and I was like, okay, I'll use a calculator. So what I did was I generated the mathematical expression. And I put X for the unknown value. And then I was like, this is a great website. And I put it in here and it gave me the number. So right now what we're doing is we are optimizing our generated expression. Like you can see the first time, like all these numbers are in here. But second time, it like simplifies the number only sections. We're trying to do that a little bit. Because here's the real one. Very long. Lots of numbers. Though surprisingly with the... Oh, never mind. No surprises. Oh yeah, this is it. This is the very long, scary number. And when we put it in here, the browser is going to be like, that's too many things, and just blah. Oh wow, it actually... Yikes. It actually says too many characters. Well, when you put the cool version in, which is the further simplified one based on caching, and we already did this math, so we don't need to do it again, then it spits out this, which the browser hates to render, but if you scroll down, you find the actual number. So we're just polishing this up now to make it pretty. As pretty as we can get, to be honest. Because I couldn't figure out the math way of doing this. I guess we need 300, 301. Yeah, 300. Which means there are 2 runs. Oh, shame on you. There we go. False true, then false bada boom bada bing. So if HUMN triple equals, I guess, last result or something. Let result. Instead of doing that, we'll just shove it in that lovely variable. Return result dot expression. There we go. It should be a little more readable. There we go. Now it spits out way down here, which is what we paste into the calculator. Speaking of calculator, let's drop that here. To such as this one. Cool. Yeah, not the best solution, but it does work, so not complaining. Now we're just doing some finishing polishes. Da-da-da-do. I mean, this hard coding is bad, but it's good enough. Hey, Intelligence, how's it going? Hi to you too. No, I'm not deep in the sauce. Not at all, whoa, dude. Feel free to ask away. Okay, we can give this thing a type. What do we want to type this as? Equation? Equation. Sure, that's a bad type. We'll call it that. But yeah, feel free to ask, whoa, dude. I'm far out of the zone now. The timer is gone. We're just messing about. And yeah, intelligence, hope your night has been treating you well. Thanks for coming on by. Ooh, fun, fun, fun. Okay, your own access token. Nice. It's gonna be fun to work with. I mean, I've used the Open API Swagger before, at least for docs. It generates pretty easily. See if the thing's still online. Hmm. Okay, the doc site would only talk to the server to post a token. Okay, yeah. So that's the great thing. You don't have to have them interlinked. It would it might make some things easier, but you'll honestly find those as you get to that point. So like if they're in the same project, the advantage is that you are more likely they're more likely not to get out of sync with each other. You're more likely when you update the other. But if that's not really an issue for you, you'll always make sure to update them, then they're perfectly fine being on different sites. You'll just have to make sure. I mean, you're making an API. Obviously, it's gonna be Chorus compatible. So yeah, I mean, it's honestly it's very slight difference between like pros and cons. There's not much code-wise pros cons. Is there a reason you don't want them together? And I'm guessing it's just separation of concerns or something like that. But yeah, I mean, and this is again a little bit way too much more for you to jump in initially, but if you implement it like as an open API, then you can get these docs auto-generated for you basically for free. This is just like Swagger UI and all that. Right, right. Yeah, I think I got all these working. It's been a while. Is this thing even accurate? It feels like I got more than that in there. Mm. Yeah, I mean, it definitely would mean less complication. So, I mean, maybe that's why a good reason, a good pro to keep them separate, to not clutter up the API with the actual changes to the docs. Because with every change, you'll of course be moving your version number around to make sure it's updated. So, keeping it separate would make it easier to distinguish those updates. Cool. Okay, yeah, yeah. I mean, that's a good reason to keep them separate. To have a clean and concise both docs and API folder structure, and not complicate TypeScript or not have multiple TypeScript projects. So yeah, I mean, it sounds like you already basically have an answer since you're going to be using Astro to make your own. That would kind of not muck it up, but add a bit of complexity to the API that the API itself does not need. So yeah, I mean, with that info, don't see why not. I mean, like I said, I haven't really dealt with integrated docs before, and on that scale, but yeah, here's a great thing. You can always put it in after. See, like you can always add it later, but it's going to be much harder. Like if you put the thing into it, I mean, it's not going to be harder. It's just going to be a little more
uglier to remove the docs from the repo, like from the API repo, because they're always going to be in there thanks to Git. But you can always add them at a later date into the single repo if you do find your advantages down there. Yeah, definitely my vote is for separate for now. Until you find a legitimate reason that's like, well, if only they were in the same, it would solve this problem. Once those start to pile up, then you can start considering, maybe we should put them in the same one. Yeah, because as you've seen with Bub and other things, when you're merging basically two separate projects into one and they're not integrated, it gets a little messy, like with a backend Express and a front end React app. You can, it's just a lot of making your own wires, which is fun, but never really comes out clean. Why are you angry? Oh yeah, we need to say as expression. Or not expression, what is this? What are you? Equation. Bada boom, bada bang. Hey, of course, yeah, I'm looking for. I mean, that definitely sounds like an interesting project, nonetheless. Love to hear how your Astro experience goes. I've only heard good things about it as far as static sites and all that go. Speaking of good things, this thing is just about done. Optimize. Okay. Well, my brain is failing me. Get log. Optimize 2022 day 21 TypeScript solution. Bada boom, bada bing. Loving that. And with that, before we go off and see how all the cool warriors did it, I do want to mention, well, where'd it go? I lost it. Oh, here we go. Yeah, so for total TypeScript, if you ever want to see the tips again, you just come back here and you clear out this little hidden tips setting. Then once you do that, look at all these. All your tips have come back. So if you ever are like, dang, I forgot all these things, that's the way to reset it. It's a bit manual, but you just go by here and delete it, and look at that. It tells you all the things, and you can mark them all as learned again. Look, a union type is type formed from two or more types. Literal type represent a specific value in TypeScript. Equations and interface, type alias that can be extended, your basic string type, all that fun stuff. There you go. Oh, geez, it's coming into it's the Whoa Dude cinematic universe almost, huh? But hey, that's what happens when you start getting into like something you can really be passionate about, right? That's definitely something. I mean, you can, well, like Leon says, and everyone says, this project or these conglomerate of projects at this point, any technical question, any behavioral question, I think, or at least the majority of them, you can answer from this conglomerate of projects. So that's great. Mark as learned. Look at this. Passing types to other types as a generic. Fancy. Okay. We don't have to go through all this again, but I already marked it. For sure, yeah. Can't think of anything what better way to do it. Okay. Okay, now let's go figure out how all the cool people did math. I bet we're gonna have like 15 of them are being like, oh, Python, I passed it to Zeta, Alpha, Beta, or whatever that Z Python library is. I bet. I just bet. Okay, come on, load up. 240, paste it into Wolfram Alpha. I tried, hey, paste the equation into Math Papa. I tried Math Papa, didn't work. I mean, I'm willing to try it again. Oh.
Maybe I was the one in wrong. Oh wait, it's gonna be down here. Glad to hear I'm not the only one who was like, please calculate my stuff for me. Okay, there's big math. Big math. Big math. Then I paste it into this thing. Watch it work now for me. Okay, we'll scroll to the end of the universe. Yeah, this didn't do it for me, huh? Well, okay, so it's not me. I mean, it is me, it's just not able to use that. Ah, then they got lucky for short input. Maybe I could try Wolfram Alpha again. I do have quite a few less parentheses. Now, I tried it with my super parenthesis version. Whoa, Madeline, thanks for the raid. Aw, I appreciate that. Had you waited a few more minutes, we would have raided you. Thanks for coming on by. Okay, that's the plan. But yeah, we're just over here finishing up, trying to figure out which cool calculator we could use. But hey, those who don't know, fellow Hunter Dever always doing some cool stuff. What were you doing today? As my bot has failed to tell me. Snowed in, but time to do leak code. Hey, we love that leak codes. This advent of code's basically a leak code every day, though some of them are harder than leak codes, of course. Man, thanks for coming by, and you too, Little Freezy, Zenetsu, and Max Techie. Uh-oh. So, I bet you spent more than 20 minutes on each problem, didn't ya? Bad, bad, bad. Yeah, you got me back. Don't worry, there are like four more Advent days. I'll get you, or after. Hey, C-Film, thanks for coming along too. Yeah, actually, I think I can explain most of our problem. So today, we did the Advent of Code 21, which I think I got a handle on it now. Oh no, Chrissy Codes, did you rate them as they rated me? Well, I swore I rated Madeline as they rated someone else too. Wow. Oh, of course, yeah, that sequel tutorial. They're always killing it. Double raid. I gave it to one person, double raid came back to me. Maybe hopefully we'll raid someone, it will be double raid too. Double raids all the way down. Hey, thanks for rating them and rating me, Chrissy Codes. Those who also don't know, Chrissy Codes, pretty cool. Where's my symbols? Over there. Double rainbow. There you go. That's right. Chrissy Codes, also streamer, always doing some cool stuff. They were doing some Laravel. Ooh, interesting. A whole variety of stuff. But yeah, today I was, of course, doing today's Advent of Code, which was a bit of a mathy one, but I can explain it. So we're given a bunch of expressions, and they're like random characters. And the first thing is we wanted to evaluate the root one. Hey, that's what VODs are for, C-Films. It'll be there forever, and then once it'll be on YouTube forever. I'm sure you would love that class, C-Films. Coming from a MySQL perspective, you'll get most of it for sure. Yeah, it felt weird, didn't it? It was like, oh great, and it's like, wait, how did we do this like twice a week plus office hours? It's like, where's my energy gone? That's right, that's right. Yeah, it's like the math here was like take each expression and to evaluate these things basically as other expressions. So PPPW was really these evaluations, where this one was this one, and this one was eventually a real number. So that was kind of the easy one. Generating all these, the first basically generating a register or an object of variables, where some of them are the numbers, and some of them are objects containing what you're doing things on and the operation in question. Hey, Chrissy Codes, thanks for that raid. Appreciate you coming on by. Oh, that's what you meant by raid into the raid. Yeah. Hey, thanks for coming on by. Again, if I made it here, I guess I don't know if that's Twitch or if that's something, but hey, two for the price of one. Those who don't know, you definitely should. Larval having fun, all the good stuff. Oh, you went to raid. I get it. Yep, you went to raid Madeline, and they went offline, and then you appeared in my chat, and I'm like, wait a minute. Hey, thanks. Welcome on by, folks. Welcome on by. We're doing a double raid. We're going to be a triple raid in like a few minutes because I am basically done. But I'll make sure to pass you off somewhere else. Yeah, for sure. I mean, I could have swore y'all were already, but yeah. For sure. I mean, wow, how are you doing that? The multi-raid, okay. You just want to hear the music, is that it? No questions. A bunch of minis. I will appreciate everyone. Apparently there were 4 left over, so welcome by, 4 leftovers. Chrissy came back for you. No lurker left behind. But yeah, thanks for coming on by, folks. We solved today's Advent of Code. If you don't know what that is, it's not Wolfram Alpha. 25 challenges released every day, Christmas at midnight. Oh no, stuck in the abyss. Wow. Yeah, exposing the race conditions. I mean, it's good, it's good. Ooh, Advent of Cyber. Yeah, I didn't know that existed, so I'm definitely gonna have to check that out. I mean, my schedule's all filled up, but probably check that out with whatever free time I find out. Oh, wow, Madeline. Absolutely crazy. Space, the Twitch was like, no, we can't do this. They started patching it out really quick. But yes, like the problem was, given this thing, you have to simulate all the expressions mathematically. We love math. Yeah, hi anyway. Hello. You are here, and you're here, and you are here. Hey, also thanks for the follow there. Above Beyond. Yeah, it was so the first one wasn't that bad, right? So the first one, like, there's a console log lying around here somewhere. Maybe there isn't a console log. There used to be a console log. Console log result. I'll show the console log because the first one wasn't that bad. Yeah, I mean, I'm always down for the congregation. So the first one, we were able to... Oh, don't look at that. Don't look at the math. So the first one, basically, we manually did this calculation with, like, registers and variables and stuff. And then we did the next one. It's a few more numbers than the original one. And then we were able to optimize it by caching a lot of these numbers. Yeah. Yeah, these ones, of course. I mean, I honestly, I wasn't able to finish the whole thing, so I kind of cheated on part 2. But part 1 was essentially generate a registrar, basically a name to value mapping object, where the values were either the number or an object describing the operations. And the second part, okay, TypeScript, I enabled this extension, it's telling me everything. The second part was basically generating a stack. Yeah, this was today's problem. Advent of Code day 21. Second part was generating a stack, basically of things that we want to evaluate, starting with the roots, that's what we cared about, grabbing out its value, and as we got to the non-numbers, we either pushed the other thing onto the stack to calculate, pushed the other thing, non-object, or if both of them were numbers, we did a little cheeky eval. Yeah, that's all you gotta worry about above beyond. You just all the things. If you want, someone actually, I believe it was Whoa Dude, put me onto or reminded me of the extension called Total TypeScript. What this does is it's a VS Code extension that it basically tries to like teach you some TypeScript stuff. So I'll turn off all the hints real quick to show how it does the magic. But it puts all these hovers everywhere, so you can hover over something and be like, this is a type alias, like an interface, but can't be extended. Then you like, I got this, and then it'll remember that you've remembered it. So you can do that to pretty well learn a lot of like existing TypeScript code base. Pretty good. Like it's pretty new extension or relatively new, so I'm looking forward to like it being able to like. So after you say you've learned something, you can't go to the docs, but otherwise you can like click learn more and go straight to the docs. Hey, whatever works, right? Wolf sheep, whatever, or wolf step, whatever gets the code working, right? But if you really did want to learn it while coding it, it's a pretty nice extension. Yeah, let me get all these squiggles out of our eyes now. Go away, squiggles. We don't want you. Go away. Go away, squiggles. Yeah. Go away, squiggles. Go away, squiggles. There we go. Okay, I think we've gotten most of them. No, more squiggles. Okay, they're all. No, there are more. Eh. It depends on your code base, see films. I think it will help anyone, honestly, because it basically makes you think about your data a little bit more before rushing into it, not to mention all the safeguards it does. That's right. Well, when it hurts you, you can tell it to be quiet with a good old any or a TS ignore. I don't. I think there are other things that will help you get a job more. What's that called? Not effectively, more efficiently, more worth the time you put in than TypeScript. Like things that'll move the needle more, basically, than TypeScript. Though it certainly won't hurt. And like there are a few positions that are TypeScript shops at this point, so definitely not gonna hurt. Well, actually, let's do the debug. So we have this tool for it. Remove all the endpoints. There we go. Come on. There we go. Okay, so we're gonna jump straight on in here. And you see, first we have our lovely register, which we'll watch that. It's a map. We love maps. Then we go through every line of our data. Big fan. It's these cute little strings right here. That spits out a key and value, which looks like that and that. It's basically splitting on the colon. So stuff on the left goes into key, stuff on the right goes into value. And then we split by spaces, which looks like this. So for expressions, it splits it into three things by space. The thing on the left, the plus, and the thing on the right. Hey, Eric Wasty, it's going, or Wastel, it's going pretty great. We're solving it, and now we solved it. Now we're kind of just stepping through the solution in question. I try. So yeah, we get those parts there, put them in a thing, and then we shove them in an object. Nothing too crazy there. Eventually, though, this does get full. Our map has all the things we could ever want. All these relations, letters to numbers, or letters to objects, which evaluate eventually. Where is it? Oh, there we go. Then we go to the more interesting one, the evaluation. Oh no, gotta delete some stuff. Oh wow, my bad. I did not realize at all. Eric, I should have realized that. Well, wow, yeah. Well, thanks for coming on by. Yeah. 21, pretty good day. Didn't exactly. I generated a expression that just generated as an expression for the end there. But so I wasn't able to figure out the math, but a solution's a solution, no matter what it involves. But hey, thanks for coming on by. Yeah. as you can see, went all cheap and I was like, okay, we can turn this into an expression. And yeah, a lot of people apparently use Wolfram Alpha to figure this out. Yeah, it was fun. My brain was like, this is great. At one point, so you can see how bad I had this. At one point, my loop was just like, oh, I can go to like a negative a million to a million. It'll surely find it eventually. Obviously, that didn't work. But my eventual solution was generate expression, paste expression into cool calculator website. Which did do the trick. As you can see, I was already here. Ta-da! I solved it. Yeah, the math is not always my strong suit. But hey, it's enjoyable even when it's not my strong suit. Generating the expression itself was pretty fun. Did make the slight optimization of caching all the non-human dependents. Aside from that, it works. Come on, VS Code. Be cool. Yeah, just going through the optimized version now. So we go through a stack approach where we grab our current thing, what we're solving for, our value. Then we're like, okay, if you're not an object, aka you're a number, we're going to skip over you. Otherwise, we're going to update our expression, replacing root with, I guess we need to put this somewhere. There we go. So you see it's going to go from the string root to the parentheses to original values. Going to destructure it, keep track of all the values that are dependent on the human answer, which in this case is nothing. Grab A and B value, which look like, in our case, more expressions. And since neither of them are a number, we're not going to go in there. Then we replace our expression again with more formatting. So just put the things. I didn't do anything. Oh yeah, this is helpful when they're actually numbers. I think we just found some useless code. This is why we always go for a review at the end. Maybe that code wasn't useless. We're gonna find out. Quokka is running, and yeah, okay. Yeah, we found some useless code. Love to see it, folks. So, those lines, they didn't do anything after all. This is why we always review it with the code. Let's make sure they didn't do anything. Gonna make sure this still works in the calculator. Bada boom. Where's my calculator? Go, calculator, go. Yep, still works. Those lines were completely useless. Love to see it. So yeah, once we found the non-numbers, we pushed them to the stack, so that way we would evaluate them next. And then we continually evaluated them until we got to either actual numbers, in which case we went through them all and we said, okay, replace the representation of the number either with the actual number value, or if we want it as a variable for our cool solver, use the variable name, which we only use for letter X. And finally, get rid of it off the stack. And we only return all this good stuff when we make it to the last or the first thing in the stack, the root. We do this to get rid of the extra parentheses on start and end. and replace the double or the triple equals with a single because that's what all the solvers love. And of course, for part 2, we actually give it a human dependence set, so that starts kicking off. We effectively run it 2 times. 1 to actually evaluate the expression badly. You can see the bad evaluation. And 2 to run it again, but with the human dependence optimized, which does actually help because there are character count limits for most of those calculators. So this is like 12,000 characters, if you couldn't tell. And this is not 12,000 characters. It actually fits. You don't need to scroll it. So, as you can see, the elimination of the human dependence works very well. And yeah, so we have a double optimized. Let's get that commit on the repo. Mend, do. Let's get that pushed up for us all. There you go. Again, if you want to peruse the code, it do be there. And I am curious to see the actual solution, or an actual non-cheaty throw it to calculator solution. Let's see if we can understand any of these others. Mini zinc. Huh. Okay. Okay, I don't understand any of that. Maple. A computer algebra system. Always learn about a new language. Mathematica. Literally made for math, so I'm not too surprised on there. Computer algebra system. Oh, just change to that. Ask for the value of root. Solve. Wow. Okay, literally built for this stuff. Here's something. What did they do? Sim.solve. Python Simpy. Don't know what that library is. Python library for symbolic mathematics. Computer algebra. Okay, yeah, that's the term that everyone seemed to be using. Whoa, QQ Impact. Thanks for the raid. Wow, that's just a lot of... Everyone's raiding tonight. Thanks for coming on by. Hey, Stu. Gupta Samarth. Appreciate you coming on by. Hexamable. And hey, good night apparently. Good night. Advent of Code was pretty good. We solved it. Oh, got this to do in here. Yeah, we didn't figure out the computer algebra system. So it was basically do math. And then it was do more math with a random number. You don't know what it is. Yeah, I mean, a lot of people did, though, Icy Black Deep. So a lot of people did. But yeah, for those who don't know, you should probably go check them out. Always a pretty cool stream over there. The bot has obviously failed. Yeah, feel free to go follow QQ over there. They're always doing some leak code or fun challenges, which is basically Advent of Code, but easier at some points. Yeah, but as for Advent of Code today, I don't know if y'all are going at it. Yeah, for sure, that would have been crazy. So what we did was, well, for part 1, I actually was cool. I did it the right way. I evaluated it. For part 2, though, as you see, I have generated the expression, and I gave it to an equation solver. I know, I didn't go full code, but like I tried a loop of like a -1,000,000 to 1,000,000, and when that didn't work, I was like, I have to think thoughts. I did partially optimize it with a human dependence, so I didn't show result. So I got some partial optimization, but at that point it was like, oh no, I don't know what I need to do. once Quacko loads, I can show you. There you go. So like the brute forces were obviously the big expression. Then once it ran through the second time, all the things that weren't dependent on the human value got flattenedly evaluated. And then you get the giant one, which is like over 12,000 characters, and then the easier one, not 12,000 characters. Oh no, you poor GPT. This is why it's gonna take over. I'm gonna disassociate with Gupta. I am not with them. I did not try to overload GPT for the record. I mean, it's all in the VOD, I suppose, but I guess, like, I thought with the human dependence that would be enough when this didn't work, and I was like trying a million to a million. That's when I kind of went for the solver and tried to find a bunch of solvers. Mm-hmm. Dang, I mean, yeah. I've still yet to actually find the non-computer algebra system solution. That's why I'm looking at the solution megathread to be like, did anyone do this normally? Because, like, they're importing SymPy, which is apparently a solver library. I'm like, how do we do this normally? Oh, generate an equation dropped into Math Papa. Okay, another one. Ah, solved with a binary search, zombie killer. Interesting. Oh, everyone, okay, there was a normal way to do it. I mean, hey, maybe y'all will I'll glean some insight from these. Same thing, but send down the value from the other branch to match. Okay, let's see what this is. So evaluate, we love good eval, parse. Okay, oh. Depth first search down the dependencies tree. So that doesn't include. Okay, yeah, I did do that. I got the evaluation of the non-human dependent side. I got that part working, at least second round. Calculate what the other side needs to be. Yeah, I guess my brain didn't get that far. Solve, simplify, parse right, partial eval. Ah. 98 onwards is good. There are 50 lines in here. Oh, I was like, wait a minute, there's another there. 98 lines in here? Okay, you got another one. Mm-hmm. 98 onward. Okay, I can understand some of this. Okay, depth first search. Oh. Oh, once you find the human, return it. Okay. So plus doing the math. Ah. Yeah, they do. That was for sure. Impressive stuff. You don't have either, then right, depth first search to it. Yes, like I kind of did this. I did this with a stack though, so not recursive. If you don't have A, find it. If you don't have B, find it. Ah, okay. This is the part 2. So if it's empty and the node's human, you found it. Otherwise, return the value of the node. A and B. Okay, I got that's the same my structure. I just use an object. Answers X and Y. Return the answer. Don't have A. Okay, I can kind of get on this. Where is solve? Yep, get all the input. Part 2, root 0. Root 0. Have X is true if human is in the subtree, otherwise false. Yeah, okay, that makes sense. Yeah, again, I did the human. I guess I did partial the human evaluation to simplify all the human routes. Oh, okay. Okay, and here's the opposite thing you were talking about. Interesting. Yeah, my brain did not think of the math to flip those around. But yeah, impressive. Very impressive, folks. Yeah, I thought about like doing some kind of binary search, like, okay, if it's too far, like Goldilocks effect, but then I realized, ooh, the value gets passed to a division, and I would not be able to figure out that math, but yeah, flipping it around, I can see is very much the solution. Mm-hmm. Yeah, these. What language Scala? Wow. Impressive looking language. Super polymorphistic. Hey, we love polymorphism around here. Big OOP. Okay, yeah. I mean, I like this. The math monkey versus. Okay, yeah. Has result. Depends on has result. Okay. Love that. Okay, yeah, I can understand all that. Find the human. Gotcha. Yep, check. Keeping track of where the human path leads to. Marking that off. If you find humans left. Yeah, yeah. So this is similar to what I did, just with the a global set, basically. So where is it? There you go. So if human dependence has left or right, then I'm a human dependent. Then calculate value, calculate input. Bam. Okay. Hey, thanks to that one, I see. Calc input. There we go. So if you meet it there, else find the two, the needed value. Uh-huh. And if it's add, subtract, okay, yeah, it's the exact same algorithm that Gupta, or at least the exact same math y'all figured out. Flip the math to find out what was actually needed. Mm-hmm. Yeah. Let me look at my expression. Maybe I'm just not looking at it enough. Oh, not that expression. No one wants to look at that expression. No. Yeah, my brain's about like no. Yeah, but I am seeing the pattern for sure for what y'all are using. Dang, impressive. Impressive solutions, folks. Oh, look, another person used that library. Oh, someone used JavaScript. Wow. Wow. Mm-hmm. X is Y equals result. If you have human and X, then you need to match X with Y times result. Yeah, yeah, that's the actual, like, solving of the equation, basically, y'all implemented. Yeah. Never was really good at math, but I can recognize the pattern for sure. I was close to going pen and paper and just being like, okay, I can just figure this out. But once I realized, oh wait, it's 5,000 or 3,000? No. Oh, looks like someone also built an expression. Split lines, expressions, get var, do. Check model. Oh, someone else also used some Z3. I saw this library again. Another cool solver. Binary search. Wow, these are some words. Oh, they actually were able to binary search it. Huh. So score is target minus. Okay, and they calculate target. Dang. Also, they also did appear to generate the expression too, so that's cool. Okay, some impressive stuff in here, that is for sure. Oh, there's that library again. Symphony. Yeah, definitely an impressive challenge. If I had more math in the brain, would have figured that out part two, but at least I know it's like, wait, there are solvers for this, so the generation of the expression itself was pretty fun. Definitely not gonna make a visualization out of this one. That's definitely off the table. What was the last one? That's that shuffling one. Yeah, we're not doing that one. But yeah, that was a good one, folks. What was last? Ah, that's the clicker game one. Okay, with that, stop this. Let's go ahead and get push force. Get that all synced up. Come on. Sync up, you. There it went. Okay, and with that, we're going to, since none of those, we're having an interesting streak of non-fun to visualize ones, we can go for 18. Yeah, we'll go for, we're trying to give 18 a quick visualization. So part of my challenge is trying to visualize all of them, though I have not had the free time. The last one we got to was 18. That Firefox, which for those who don't remember, was the cube one. Oh, come on. Well, this was working when I last touched it. There we go. The cube one. Where are the cubes? There it is. It's this one. So I shoved this into Three.js. I think I was on day 18, and we somewhat visualized it. Now, obviously, this is very manual, so the automated version of this would be to make this visualization a little bit more fun. Well, lots of... Yep, come on now. So first thing, we'll be placing these bricks a lot quicker. Okay, go fast. Yeah, first time really messing with Three.js. Then it'll be swapping their actual view around, probably either at a angle, so somewhere up here. Man, it's going slow. Okay, first thing, we're increasing the movement speed. Gotta go fast. Well, how do we say this? Move speed equals 10. We also want the thing to actually point at the direction. So, want to look at. I also want this raw queue. Let's move this up. Boop. Yeah, put it up here as a big, scary global. So now we want const center coordinate, which will be that's not the center coordinate. Yeah, sum divided by length. So sum, so for const chord of Q, or what should I call these? I call it a Q. Might as well map over all these. Map line dot splits, comma, map number, coordinate of coordinate. We have the coordinate, sum them all together, and then const center equals sums dot for each of these sums. Beautiful. Now we want our camera to look at that position. So look at center. There we go. Controls, target. Don't feel right. Point camera at center. No. Camera look at center. That feels right. Then position this. I guess we'll want to position it somewhere centered but off. Let's see if that works. Using all these that's either an error or a bunch of CDNs loading. It is an error. Chords is not defined. Of course, because this is Q. Lovely. Whoa. Shift split. Alright, because we ruined that. Yeah, because we pre-parsed it. Why are we using shift? Oh, because it's the proper order. We can fix that with a dot reverse. So now we can use pops instead. Be efficient. There we go. There they go. Okay, they're all showing up now, and we are looking at the center. We're just way down here. So we want our Y to be basically center Y. And our X and Z to be half. So camera position dot Y equals center Y. Then X to be center 0. Alright, let's just try all three of them, to be honest. This should put us literally in the center. And it's just a theory. Yes, we are in the center. Glad to see it. Why is this mouse thing doing this? Mouse control. Mouse drag. Nope, that's... don't feel like it. Okay, we're in the center, so I guess we just want to be 10 off. So, plus, we want X to be 10 off. Okay, 10's a little close. 15! We should increase the spawn rate of these to spawn all the time. This is limited on 60 frames a second, so it might... okay, it is actually faster. 15 apparently is too close. Could do some cool math to figure this out. But, spoiler, as y'all tell, not my strong suit. Yeah, whoa, dude, we're gonna... since all these last ones have been not visualizable, we're gonna try to get this one at least somewhat up. This is from day 18, if you don't remember, where we had all these cubes and we had to visualize. Well, we didn't have to, but we had to figure out the internal versus... well, we had to figure out the number of faces that were externally facing. So yeah, this is the Three.js visualization of that. Yeah, well, I guess we're gonna try to make this... okay, this is going really slow, but we're gonna make it go faster and, you know, some kind of animated thing. For loop this, and I guess for every render. Technically we want this duration based, but and we're gonna figure that out later. Slowly learning Three.js through this. So how do we turn off... we need to look at the docs. What's that back? For fly controls. There's some docs. Back when we did this before. Hey, appreciate the fall there. Zombie killer whale. Auto forward. Drag to look. That's what we want. Or that's what we don't want. So... controls drag to look equals false. And let's make this faster. My mouse is still doing the thing. Why is my mouse still doing the thing? If set to true, whoops. read the description, maybe. There we go. Now moving my mouse doesn't mess it up. I have to actually click and drag, which, lovely. Oh, great. Yeah, I love this trick. So yeah, that's looking better already. What's my roll speed? I guess that's fine. Here goes the fun part. We want to rotate. I mean, it depends on how the visualization we want it to go. So I do technically want to write them in the order they're found, but I want them to go a lot faster. So I want this to have a duration of like 60 seconds. Let's make it, yeah, 60 seconds. And then let's just say cost start equals date.now. And then based on this, we'll figure out how many we should draw. It's technically how many left we should draw. That's a little bit of math, but basically by 60 seconds, or in this case for testing, 10 seconds, we want them all to be drawn. If there's nothing there, obviously do that, and then many cubes to add. Maybe that'll work. Elapsed, num to add. That seems right. For let I equal 0, I less than num plus plus. There we go. Let's see if we get lucky. Of course, we're eventually going to hit the end of this, so we gotta make sure to do a check in here. If not queue length, return, you're done. Yeah, let's see. Well, my math might be off because I said it in seconds. Yeah, let's increase that to milliseconds. Where is it? There we go. Let's see if that's more accurate. So starting on 11. I broke it. Big fan. Or nope, math just got away from me. So num to add. Let's console log. It's gonna be a lot of console logs. Elapsed. Num to add. Oh, nope, now it's working. Huh. Okay, I mean, we still need to see this value, I suppose. Gonna be a lot of console logs, but we gotta see. Num to add. Okay, so it's requiring elapsed to go up really high. That's not what we wanted. So, again, bad math. Good idea, bad math, though. So, elapsed is... Basically, we want to calculate the ratio or the how far we've gotten along till the end. So, not up here. Just down here, it'll be cost end equals, and that'll be math. Hey, thanks for all the follow there, Hexamble. Hope your night's been going well. Or your evening or day, whatever time it is where you're at. Start plus duration, and then cost ratio equals, not elapsed. No, it's start. Yeah, so let's figure this math out. I'm supposed to be finished off, if it's 2500, I'm supposed to be finished at 10. 0, 0, 0, 0, 0. There we go. Nope, that's not it. Yeah, it's the first one. So small divided by big. The ratio is there. That means we should have that many added. So it's this times the length we should have added. So num should cost. There we go. Cost should have added equals the elapsed time minus divided by the duration. There we go. So it's this, because I don't trust that. Didn't need the ratio. By this, for I should have added. So we'll need to go through these and check, hey, have I already drawn you? Which means the queue gets an upgrade to that data. So congratulations, you're a bunch of numbers, but you're not just a bunch of numbers. You are... Do-do-do-do. Do-do-do. Well, you're gonna be a bunch of numbers. So it's gonna be, I guess we might as well destructure you. Const X, Y, Z, make you a cool object. X, Y, Z, and then we're gonna call this, box null, lines null. Yeah, so if either of those, that means you are officially drawn. Chord of chord dot. Now we can draw these directly, like so. Okay, great, that's what we want. Get rid of this one now. This was old code to try and draw these lines on the boxes, which apparently I didn't need, but keeping it just in case. So for every one, we're going to be like, hey, Q, I. Well, that's not how we're going to access it. We're going to say const. What are we going to call this? There we go. Not popping you anymore. Congratulations. Drop that. Q, I, if element dot box or element lines. That means you are drawn. Congratulations. Now we get to say element lines equals line and element cube or box equals cube. Let's refactor that. And let's refactor lines too. Technically you're the weird one. You get the refactor. Lovely. And yeah, random color, white lines. Should be good. Let's see if this does the trick. Ah, no, X is not defined. Well, that's in my animate loop somewhere. Whoop, I know what's wrong. X, Y, Z. There it is. Const X, Y, Z equals element. Thanks for the auto format. Oh, we got one in here. One made it through. Are we still failing? There we go. Okay, I wasn't exactly counting 10 seconds, but this feels like that took 10 seconds. Oh, great. And now... 2104. Okay, stop. It's not crashed. Oh, crash the browser. I'm imagining it's not element, so if not element or this, because the math does its cool thing, I guess. 1 point something. I think this should be math.max q.length. I won't need to do this check. We'll find out. This time I'm actually going to keep track of when I start. So we're starting at 35. Wow, how fast. Of course, I said max, so it's always gonna, like, draw them all. 45. $56. Okay, yep, that's how math works. Because they're timeouts, they're not do it in this second, they're doing it in at least this second. And as you can see, computers like, how dare you draw so many cubes so inefficiently? Once we get in here. Yada. Oh. No. Keyboard controls. There we go. Okay, so that's the fun part. And again, we might have a few customizations on this. But now what I want to do is for that 10 seconds, I want to rotate around the center. How are we going to do that? This is a good way to figure out. Camera around point. Oh, didn't mean to drop that tab. Rotate. There we go. I guess we don't need them. I'm keeping them here because I thought they'd be cool to look at, but We're not really using them. Effects Composer, oh, goodbye. Cool things that didn't work. Okay, let's see. These are good, these are good, these are good. Yep, add that. Add controls. Hello, camera. Where's camera? You live your life up there. Cubes. What's this doing? This is doing nothing. Say goodbye. I'm using controls orbit. I don't want to do that. I want to... Oh, this is close. In case I don't want to use this. Rotate Y, copy of mouse rotation. To a boom group. Okay, let's add a boom group. Cool. I love that. Hello, camera. You're going to get added to a boom group. Okay, so scene group. I guess camera needs to go first. Okay, so I guess we might be not setting the camera to do stuff. Boom's length. I think that's like 20. Camera looks at the boom 0, so I change the boom to be all these things. Where you at, boom? Hey, boom. And there we go. No, I don't think the boom looks at anything. Camera looks at the boom. Just see if this at least visually looks right. Hey, that's at a 45-degree angle. Don't remember asking you to do that. Interesting. Maybe shouldn't tell the camera to look at anything. Ah. Okay, let's add the last bit of code, I guess. Yeah, so let's do it right here. Oh, okay, that's doing a thing. So the boom's located out here or something. Oh, 17.5. Why is it in the middle of space? Because I put it in the middle of space. This is nice. Let's go a different way. Also, I should really do this full screen to get the full effect. I like this. I don't like my browser dying, but... Oof. Browser, why have you abandoned me? Okay, this is what I get for not using the delta, right? Yeah. Too many renders. Okay, what if I add them and just toggle their visibilities? Because I think it's the creation that's all, this is too much. So, okay, wow, this is being a bit of a chug. I mean, at this point, I'm just, okay, I am technically still looping over them, right? So, if should have added triple equals q length, then return, right? So you can still do math, you just can't loop over all the things. Okay, I guess it's somewhat of an effect, the slowing down. Not the intended one, but it's an effect. And is that rendering, or who's to blame for this? I know the cube's a lot of work. Well, we need to add something to this thing to say rendered. Rendered equals true. Congratulations, you just got a boolean. So what if we didn't actually render it? We just... Well, this is going to be a real awkward rotation. There's nothing here to rotate around. Wow, look how fast it's rotating. Okay, so I guess we need to at least add lines, just to see who's to blame. Okay, let's not get lost in the matrix now. Yeah, okay, I'm gonna guess these performance impact is practically identical here. Oh, geometry's not defined. Apparently this is for both of them. Y'all need geometry. Oh, this almost looks better. Yeah, this is working. Maybe I should put the request at the end of this just to jerry-rig the timing a little bit. Mess up the frame rate, but the playback rate is practically the same. Oh, wow. Camera controls are real whack. Okay, so put that back. I don't know what I'm doing with this delta. Hills or something. Okay, so we do gotta add both of these. I guess we can multiply. What is clock get delta? So I can multiply my actual rotation by that, so it's not impacted by the actual clock, by the actual delay. Get delta, seconds passed since old time. I guess I can multiply this times delta. If you're small enough, it won't hurt. If you're big enough, it'll be really fast. Wow, you're pretty small. Let's multiply that by 10. You're awfully small. Let's multiply that times 7.5. This is a little better. And look at that, very consistent despite the computer wanting to not live anymore. Okay, that's a bit much. Down to 0.5 is going to be the happy medium in my book. There we go. Now I do want to increase the z of this entire thing. So times 2. Okay, maybe 1.2.5. Oh no. I meant z as in vertical. I have all my x's mixed up apparently. Yeah, there we go. Now it's about too much, so 1.25, and I do want it to look at the center, so one of y'all gotta be looking a different direction. Ah, not like that. Camera looks at boom 0. Maybe I need the boom to look at center. Well, someone's gotta look at center. You'll see if this does the trick. Yeah, there we go. We're slightly elevated, but we're looking into the center of it. Performance be darned. This is what we want. Now, once the actual placing is done, what we're going to want to do is we're going to want to, so technically different placing algorithms, bottom, top, top, bottom, all that fun stuff. Let's experiment with that. So I'm happy with this. 20. Yeah, when I'm not head dev, that fills the screen. Yeah, whoa, dude, that's part of the fun, right? Oh no, I pushed it away. Yeah, we're gonna mess around actually right now with the way that it builds. So q dot sort a b, then const x diff. We're gonna try to return. There we go. We're gonna try to make it do it axis by axis. Now, if I can already tell I have these coordinates wrong. There we go. It's building by layers. Now this is the wrong layer because I think, like my brain, the z-axis is vertical, but programmatically, like it's on its side somehow. So we're just gonna figure out, swap these around till it's going the right way. There we go, bottom to top. And it's doing that from there to there, which is working. It's not the one I was imagining. I'm imagining a more of a circular one. Okay, we do know y is the correct one though, right? So if we return 0 here, they just live their life because x is left to right. There we go. It's basically random from there. Now from this one, we want distance to center. Const dist to center equals... Ooh. Okay, I'm gonna trust Copilot. It's a 3D printer. Shh, no. It kind of is, I suppose. We want both. So A dist to center, and then B dist to center. Turn, well, B. There we go. I guess it is a 3D printer, huh, whoa, dude? Okay, these distance algorithms are obviously failing us. X is 0, Z is 2. Okay, we can console log. I mean, this is supposed to be... Doesn't really seem to be doing anything based on this. It's completely randomed. Return AZ. Let's see what the Z axis, how that affects it. Yeah, it goes that way. And the X axis should have practically... Yeah, it goes the other way, right. So we're using X and Z to determine... That is what center... I did calculate that, correct? Yeah, X, Y, and Z, 0 and 2 are the one I care about. Let's console log center. I know I can't console log inside that sort. That would throw my computer out a window. Yeah, so center is basically the 10th coordinate. Correct. And I'm supposed to be subtracting by the... Okay, let's just see if we can just ask this again. Sort by distance to center. Oh, you're doing something. You did a different algorithm. You put a math square root in there. Copilot. Ooh, look at that. Inside out. Now we just go outside in. So I think that'll look cooler. My brain says this looks cool. Now if it were spirally, that would be even cooler. But we ain't got all day for that. Now, this all looks pretty good under 10 seconds. But it's gonna look really good when it's actually taking its time. I think we're spinning too fast. Yeah, it is plenty cool. I know. So outside in. Yeah. Computer's like, hey, don't do that. Yeah, look at her go. Okay, we could have a more vertical angle at this point. Let's go higher. Yeah, so 1.5. And then let's decrease the speed down to 15 seconds. Okay, it might be a little too high. Yeah, that's pretty good. Okay, we could be closer at this point. As you can see, it does not completely fill the screen. So, oh, that's set at 20. Of course. Oh, 20's, that's too much. 17.5. And there we go. I'm liking this so far. Now, because this is all just like, cool, visualizing cues, but the solution, or like the code, if we remember, the first one was counting how many faces were touching the world, or like touching air, basically. So doing that visually, I think that would be as simple as kind of like this code here, going for every cube and highlighting all the faces, and when you get to a face that's not that's not touching a cube, you... Oh, yeah, okay, I got it. To scale this into a visualization of 60 seconds is going to be a lot to ask. So that's why we're only doing part 1, because part 2 is the cool one, where we actually essentially do a flood search. How do we do flood search again? Yeah, we go through every coordinate, starting at top left, and kind of come through like a mist. And everyone we touch, we mark. Everyone we can't, we don't. Yeah. Yeah, we'll go for part 1 for sure. Not so much part 2. So we have our lovely cubes, and we are sorting them all out different ways. Let's keep our original sorting, though. Const render queue is the old queue, but sorted. There we go, render queue. Big fan of render queue. Live your life over there. And technically, the lengths are the same, but let's do that. There we go. Now that I'm looking at it, it's a bit of a fast for my spinny. Lovely. Now, for the actual solving, we went through all the cubes, we generated all their neighbors, we scanned, and then we were like, if you weren't a person, like you weren't a cube there, then we did the thing. Let's go like this code, this great looking code. So I guess this is technically after fully visualized. And then, this is elapsed. This is stage duration. Kind of hard to pick out what I'm doing here. What we want to do is, every second. Okay, there was some Copilot code I ripped out of here. No, not elapsed. Oh, geez, I'm using normal clock logic. It's not good code, but it's okay. So what I want to do every second is we want to... Not TypeScript. Okay, not bring your own function. Drop the types. Boop, 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 boop. Ba. There we go. This is a cute little generator. It basically spits out all the relative touching X, Y, and Z's for a certain cube. So what I think we want to do is we want to take all of the neighboring cubes. So how do we decrease... Okay, we love you, visualization. You gotta go. 3JS set mesh opacity. We want them to turn to ghost blocks as we do this. Float in the range. Cool. This looks like what we want. Dot opacity. And what is this on? A material. Mesh basic material. Okay. Line. Okay, great. I have that. Oh, I can inline this. Let's go. Geometry, so we need both of those. Okay, so these are our materials. Random color, random thing. What we want to do is... Okay, I'm gonna break the rules here. Tick. We're breaking the rules. So once we actually render the thing, because I want to do this in function calls, not. As I'm fighting this animate function. I'm already breaking rules here. Breaking all the rules. Oh, what the? Weird music. So technically we don't want to do this every second. We want to do this every 10 seconds because there are 9 faces, right? So every 10 seconds. Get that maths out. You want to start the process. Implement process. So how do we do this? We go through every cube. Okay, so this will be let ci equals 0. Then const cube equals not render queue, the normal queue. This is our, there we go, ci plus plus, give value, then increment. Great. X, Y, and Z. There we go, for all the neighbors. Ooh, okay, I'm liking this. if cube, set the hex to green. Okay, well, first what we want to do is for cost cube of q, set the hex. Okay, how do we do this? Set opacity to 0.1. That would have been cool, Copilot. Okay, so cube material opacity. Opacity is a thing. Is there a number? Like, how did you, what's a color? If only I had TypeScript. Dot color? Color right. No, that's, the heck? Whether to amend the material. Material. Oh, so color, wait, it's literally right here. Well, that's Copilot. Maybe it's not there. Mesh basic material, line basic material. Okay, let's just look at opacity. If the material is transparent is not set to true, well, that's awkward. Let's not forget that. Oh, hopefully my computer's about to be like, what do you think you're doing? Okay, so what we want to do, every 10 seconds, we want to set all the cubes opacity. Cube dot material set. Okay, we'll just do colors. My kid, let's not get too crazy here. Let's drop it down to every 2.5 seconds. So we're going to set all of them to green, then this one to red. I might not be able to actually see it because it's in the background or whatever. Yes, this is once you finish rendering, which we can make that go real fast. Render in a second. Wow, so fast. Okay, they're all green except for the red one. We can't see the red one. Okay, everyone gets a low opacity so we can see the red one. Which I think is just 0.1. Would that be cool? That would be cool. Oh Lord. Huh, the lines need opacity now. Or the lines need to not exist. The colors aren't changing anymore though. These lines, they were an idea. Maybe they're not such a good idea anymore. Oh, wow, it looks weird though. It looks a cool weird. Wow, okay, my eyes do not like this. I mean, they do, it's just, woo. Okay, let's say goodbye to the lines. They were an idea. Let's not go with them anymore. Colored blob. Yeah, we love colored blob. Big fan of Bob the Colored Blob. Okay, so this is now doing its thing. Null has no properties. Well, okay, this got angry. So when I added the opacity, it was like, we're not going to color it anymore. You're not going to color any of them anymore? Yeah, wow. Okay, so one of y'all are failing me. Oh, and this is exactly 2.5 seconds, isn't it? Yeah. Elapsed modulo 2500. Was I literally just lucky it happened to hit that? Oh, I was the luckiest duck, huh? I guess I need to say every... Again, this is the weird thing. My brain's not liking this logic. Okay, what's the... 3JS way to schedule events, and oh my goodness. Stop console logging. No, not schedule events. It's this clock. What's this magic clock thing do? Keeping track of time, right? Yeah, let's figure out how we do this thing. So you want to do something every second, basically. Elapsed time running, stop delta. get elapsed time. Uses performance now or uses date. Okay, so it doesn't really seem to be doing anything magically for us. Every 2.5 seconds. Don't use elapsed. No. I want to use the cool clock. Do 2.5 seconds. If date.now starts greater than no. Add a sure. No. Trying to figure out how to get this scheduling thing to work. Run code every X seconds. There we go. I'm trying to do this the proper way, not just throw out a bunch of set timeouts. Okay. Okay, time delta. Add scaled. What the? Yeah, so we have our clock, time delta, speed times. I just want to do something, not scale a movement. You could use throttled, execute once a second, or set interval. 222. My brain's not liking those. Actually, that might have been a solution. Let's go back. That's basically like a debounce, but in the inverse. There we go. Throttle. Nice. JS throttle function. This will be good enough. I just want the code. Just give code, please. Please give code. There we go. Previous call time. Da da da. There we go. This is what I like. Lovely. Okay. Big fan. Big fan. Wow. Auto format. Thanks. Where? Thank you. Okay. This is our lovely throttler. So this is going to be const. What are we going to call this? Cool function. Process cube equals throttle function. Cool function, we want this every 10 seconds. And then once you reach the end, you're gonna call process cube. And this will do all of this. I might as well return it because we're not gonna put you through that loop. Well, there's actually stuff to do in that loop. There you go. Okay, so for all the cubes, say goodbye. For my cube, set you to red. Now the opacity was freaking out because we didn't actually have any of this possible to happen. So opacity 0.1, we should be able to see it. And while we're here, console log cube.material, so I can see what stuff we can mess with. In theory, this should run the first time, not the rest. And how are you using this? Using date.now. Which, I mean, that's fine. Sure. Everyone loves that. Oh, that's broken. Look at that. A lot of them are green. They're not all green, though. Okay, now they're all green. And we have some stuff here to look at. Do we have an O? Give me an O. We're not seeing an O here. Oh, opacity. There it is. Okay, we got this. We set all the other opacities. Cube.material. Opacity equals 0.1. Congratulations. We can't see you anymore. And of course, we set our current cube opacity to 1, of course. Yeah, 10 seconds, a bit much just for this visualizing part of it. So let's see what this does. Hope someone didn't like that. Did I typo? Okay, 0.1 is not. Dude, I can still see you. You don't like running on the first one. Cube is null. Boom. There it is. That's... Okay, the color... Oh, look at that. It's going between the different ones. Okay, now we got a console log line around here. Let's not do that. Okay, I understand this function. Big fan. Don't need all this. Cool. Loving that. Let's not set it to green. We can leave the colors as is. That is a bit jarring. Still got consoles? We don't. Okay, I see why the one's failing, because they're all not cubed up. But, ooh, there we go. Now, that was a bit strong, I will admit. Okay, I'm liking this. Big fan. So what I want to do is technically animate this opacity. I guess we'll do it in stages. So if we make this asynchronous, that means I can do some delays in here, which are going to be time-based, not frame rate-based, I know. But... Wait, can I do this with all the throttle stuff going on? I don't see why not. So if I just async await, then additional calls won't wait. Oh, okay, that's a great scheduling thing I just threw on myself. If I build it into the time though, okay, we just do more math. So you're gonna take 10 seconds, and then congratulations, you're asynchronous. Make our cute little delay. This new promise. We love it. Classic delay. What we're going to do is do this in 3 stages for let O of 0.9, 0.6. I guess we're not doing these stages. So it needs to be 0.01 by the end of this. So 0.9, 9, 0.5, 0.01. Might be too much of a drop, but we will see about that. Increment that. Await delay. Then I guess you'll put 250 milliseconds between each of these. Oh, we also don't want to color this cube, but we'll see how that pretties out. Let's make sure that we don't get caught here. Because this is why that explodes, because we run it before the cube gets added to the last one. Okay, let's see if this looks good. Ooh, it's all hard-coded, and my delay function ain't doing its job because you're not a function. You're just a weird promise that exists in the universe. Boop. This is how you're supposed to animate with 3JS, folks. Ooh. Okay, it is a bit strong. There we go, that should be enough. And for each of them, this will take a second in total, so 10 of them. That should be good enough staging. Bad, but good enough.
It feels like each one of them took 10 seconds. What is up with that? Well, it's because I hard-coded it, of course. So, okay, again, I gotta make sure. 1, 2, that's 1 second. Yeah, again, because there's no waning, so I gotta keep the math manually going good. Hey, look at that. Okay, man, that last jump, my word. 0.1, 0.05, 0.01. So, quick math. Length. So 100 divide 10 is that, but 11 is 90. We'll just do 90. Again, this all is estimative. But there it goes, and now we hide the one in question. Here comes the fun part. Okay, well, the fun part is that we don't get rid of the cube in question. So cost target equals, not this one, this one. Okay, for cube of q, if cube triple equals target, continue. Don't touch the chosen one. The chosen one shall not be touched. Actually, I guess your opacity is going the other way, huh? Well, that's on the first render. Okay, subsequent render is going to look a little different. Let's not get lost in the sauce. Let's just see if this looks right. There we go, and the one is there, perfectly visible. Now, the fun part begins. For each one, for each direction we're going to go for, basically, well, don't do that. We're going to create lines. I guess we're going to use one lines, technically. Let probe lines equals... I guess we don't have any probe lines, so the first one will create it. Yeah, so we go through the queue, we try to find that one, correcto. There is a cube. Actually, it doesn't matter if there's a cube. We're going to do this no matter what. So we have edges, lines, scene add. I guess, okay, so probe lines are always going to exist. Welcome to the world. Make a geometry for you. Apparently you need that. There you go. Transparent true. No, you're a real boy. Now your position, though. Who sets that? I guess I set that. What's your initial position? 0, 0, 0, maybe? It's not unreasonable. Hey, appreciate the follow there. Experimental film. Doing a fair amount of experimenting ourselves, as you can see. So I guess this is probe lines. What we're gonna do is when you're here, your family now. Probe lines, position, set it to there. Then we do a lovely little, oh wait. A second, I suppose. And then if cube. So what are we doing? We're counting air. So I guess we're having a count somewhere, but we're gonna want old color. Cost old color equals, there you go, get hex. And then if cube is set this, there's always gonna be a delay. Else we'll set probing cube. Where's probe cube? We need a probing cube. How do I make those? I guess we can say goodbye to those. Just like this. There we go. Bubba geometry, like another hard-coded one. Now you're saying you're white. I guess white's when you're saying you're random, you're not saying you're white. I guess white's not a bad color. Might tune the opacity down. Although I do want you to be visible in this thing. So 0.001's that. I think 0.5 will be enough.
I don't remember what lines look like. I can't believe this thing's still doing its thing. That's neat. Oh, for the additional, okay, for the initial, I guess we're all going down, but for the next ones, it's supposed to take the one down and the others up. We'll figure that out. Okay, so we have a probe cube, probe lines. So what you do here is if cube, I guess we set lines. Yeah, all of this technically happens here. If cube, otherwise, probe cube, position set. Then we wait. Oh, hold on. Hold on a moment. Then we set the color back, right? If cube, set color back to old color. Okay, we'll have to do the initialization of this later, but let's make sure. So this is for all 9. So this is 9, basically another second. So we have 1 second here, 1 second here, under 10 seconds. Let's see. Oh, look at that. That's at 0, 0 coordinate. That's not where it's supposed to be. The opacity looks a little strong. We can tune that. 2, 5. Let's see where our error is. Cube is not defined, of course. Cube, cube, probe, cube. Cube is not defined. Which one are you complaining about? Line 50. Well, something ends in 50. Nope. Eh. Where is it? Where is it? Process. Yeah, which line? No. Process cube 2152. 52. Well, aren't you a complainful one? Okay, because I don't want to show anything. So we're not moving the cube position. I can tell that. So target cube, cube, cube. This is, whoa, that's a problem. XYZ of target. There we go. Had some old variables living around. Yeah, I got lots of naming improvements, but we ain't there yet. Okay. Cannot access lexical X before, of course. This is generate touching cubes of, yeah, 2x. Wait, which one are you complaining about? Why are you no happy? 2150. Man, these this it does not like giving me stack traces here. That's cool, I guess. So we're accessing X before it's available to us. For X, okay, I understand, kinda. Target dot. Target dot. Target dot. Will that make you happy? So now you have access to them, and you can do all your favorite activities. So look at that, it jumped around to the positions. Now why are you angry? Why do I keep looking at this error? It means literally nothing. 2193? No. 2122? No. No, no, no. This async really gobbled up my stack trace, didn't it? We're talking to a cube somewhere, and the cube don't exist. If cube, cube, cube. So we're doing our conditionals. Wait, is this thing still working? Yeah, we're also doing this on 10 seconds. Which does not need... I look away 1 second. You go do cool stuff. Okay, the lines are working. The probe cube is not following. We also need to send that thing back to the shadow realm when we're done. Probe cube is a mesh. We can do stuff to it. Type error cube is undefined. Oh, I'm only touching the cube like 2 times, so in theory, it's got to be one of these. Ah, here it is. Cube, cube. There it is. Whoops-a-daisy. And cube is undefined. There it is. So if it's undefined, then you'll do the nullish consolidating. have your fun. Oh, the probe's a little bit. Oh, the probe. I see what the probe does. It goes to the ones that I do have neighbors of. I guess that is the behavior I was looking for. 9 and 3, that'll do it. Okay, 5,000 might not be enough. 75 hundo. Always move the probe cube. I guess these ones are doing this. Then we want to cube opacity back to 0.5. What's my probe look like? 0.25. 0.25, and then set it back down to 1, where it belongs, in the zeros. Ooh, I'm liking that. Okay, we should teleport back when you're done, right? So go back to the... I guess just setting your opacity to 0 would work, but we'll set you to the universe probe lines. We can just disable the rendering, right? There's gotta be a programmatic way to just, like, be invisible. Dot visible. That's amazing. Too many tabs. So we can just be like, dot visible is like, nah, nah, nah. Probe lines dot visible equals nah, nah, nah. Right? Gets rendered if true. Oh, okay, I was about to be like, is this a reader? But no, we're cool. So yeah, you're not visible. Then here, you are visible. And then, you're not visible. Nice gift disappearing trick. Also want probe cubes to do its thing. As probe lines is always... And this toggle ability might not be fun, but it will do the trick. Probe cube. And then after this one, you are not visible. False. Whoa. Get back down there. False. Okay, let's see if this looks good. Okay, the gray thing is initially visible. Let's fix that. There you go, probe cube. You gotta probe cube visible equals false. And this is making me think of a good idea to fix our stuttering at the beginning. We render, then only mess with visibility. Hey, there's all 9 checks. Oh, we want red for bad, not that. So what is it? Red, green, blue. So FF00, F00. Yeah, red for the bad, green for the blue. That's not how we're setting the hexes. There we go. Yes. Ooh, I saw that. I still think I didn't see that. Get back here. I can't move. Okay, this is cool. So what we want to do here is, while this is good, how does my throttle work? It just throws it away. Great, that's exactly what I wanted. So this animation, this super fading, is good, but we want it to not be jumping back. So we want to do the super fade once and then the rest. Now these timings... Okay, so we want super fade. This thing happens once. And we don't care about target cube. So cost super fade all. Throttle function. And it's, yeah, again, my timing. Wait, let's see. Let's stage equals, yeah, we're going real bad here. We're using staging now. And we can just shove this in the actual event loop. And then it's going to be if stage triple equals init, init. We're going to do this, the great fading. Oh, great, and we're doing async await. We call our cool function. fade all. Again, Batty's writing bad code. We just want pretty cubes. Else, and then what changes stage, of course, is our function. Fade all. Yeah, that's not what we're doing in here. Congratulations, you get your upgrade. Ignore the target. This does the trick. Hey, thanks for the follow there, Kelly Trick Them 513. We're just doing some neat Three.js visualization of an Advent of Code problem. Not today's, like a few days ago, fortunately. Yeah, so we want to set stage equals undefined, stage equals processing. Great names, just messing it up. If stage, else if stage triple equals processing. So the battiest of bad. So this should, we can also reduce this to 5 seconds probably. And fade all. I don't think that'll get ran twice because it is synchronous. Though to be sure, I can make sure by doing this, which I know is bad and you're not supposed to do it. I don't think no one's gonna miss a few frame jitters. There's the fade all. Okay, it did the thing. It's also... Okay, I thought I was seeing something else. Okay, that's cool. What we want to do for this is... Sorry, I lost my spot. There we go. So we want to... We also want the old cube, right? So let old target equals QCI minus 1. This is a const. If not old target, well, we don't want this. So technically, we do want to go through the fading process. So surprise, surprise, you're back. But we don't want to do it over all of them. We want to do it over these two. So for let O of this. So yeah, so we're setting the old one to fade out, the new one to fade in. So I guess I can just do with math, right? Hold on, let me figure out math. Capacities equals here, and I guess you'll start out 1 for let I equals 0, I less than capacities. Yeah, length. No, not whatever that is. I plus plus. There we go. And const j equals opacities. Bingo bango. So my target opacity is going to be increasing. Get up there. So target cube material. No, what the? Opacity is going to be the current one, and the other one will be decreasing. Nice, and 90. I guess this will have to drop to 80 because we're doing more opacities technically. It's either going to be the right way or the wrong way, so we'll see real soon. That's the wrong way. There you go. So A-I-J, J-I. Okay, let's give this a quick looky-loo. There we build up, fade out, fade in, do the processing. Nice. Nice. Okay, I'm liking this. Okay, now this is taking a good time, right? It's going good time. What if we told it to go as fast as possible? Would that be finished, or would that be limited by Three.js rendering times?
Ah. Okay, now we're dealing with the debouncing or whatever, right? So let's remove that from the equation. You go as fast as you want. Okay, this is getting closer to kind of what I want it to eventually get to. Because I want it to start off going oh, too fast. I want it to start off going slow and then crank itself up by the third cube, I guess. So this will be const delays, which means my throttle will need to be updated. This is great. Throttle. I guess we'll do a cool thing here where our const new func. Congratulations. And then new func.set delay equals new delay equals delay. That works. Don't know. This is JavaScript. We do what we want. Awesome. So our delays are 80 for the fades, 333 for those, and the global one, I have that set as 5,000, but I know that's wrong. So we have this one, and we have this one, and then we have the when we're ready delay. Let's just turn them to lower numbers. And then, yeah, because it's 80 times 10, so that's 800 plus 100 times 9, 900, 9 9's 18, 2,000 seconds. Or 2,000 milliseconds. There we go. Now, this will be all delays. All delays. If CI greater than 3, will be const delays equals CI greater than 3, which we can literally use as the index. Nope, not like that. CI greater than 3. It's not the number 3. We will turn this into a number with a good old unary plus operator. So if it's true, it's the small ones, otherwise it's the big ones, and then we're going to say delays 0, delays 1, and of course we're going to update this internally like baddies by saying, okay, not saying that, process cube dot set delay to delay 2. I guess we'll hard code all delays. 0, 2. Make it all that. So in theory, after the third cube, it'll start zooming. Now something's angry about target. I guess I'll figure that later. Target. Ooh. Oh, that's always something real. Cannot access lexical delays. Oops. Yep, got all these variables lying around. Yep, a good speed. Oh, okay, you nope, we bad timing. Okay, you are picking up speed. I like that. You're spending a lot of time on these, though. Spend, like, no time on those. Appreciate it. Which means this drops down from 800 to, like, 1,500. The initial timings are a bit much, though, and we do eventually run out. So, if not target, return, and I guess we might as well stage equals done or something. I haven't even gotten to a done stage, but stop running this code. Okay, we don't have enough time between these, so we have 5,000, which is 1, 2. It needs to be 0, 2. There we go. I was like, why you go so fast now? Because I told it. The manual. Look at that. You can use your eyes to track it. And you can do that for 3 of these cubes. And then we're going to be zooming. Let's zoom. Okay, I'm seeing how we, like, wait for one to finish before going to the next, which is cool.
We don't need to wait though, do we? I mean, like, if we schedule them on top of each other, it might mess with the opacity of the previous one. Which means we might need to wait. Okay, let's change that 3 to, like, a 0. So the first one has a cute presentation, then we zoom in. Present yourself, purple cube. And now get out of the way. Okay, yeah, it does start to fade the old one a little quick. That can be improved by decreasing the timings and not doing delays for no delays. So if delays 0, because await 0 is technically an await. So that's good. Let's drop this down to 25, which will increase it by 4. Yeah, I like that. And I haven't even thought of the actual duration calculation for this, which is what I should be basing all this timing off of, but why'd that go slower? Oh, now we're going fast. Ooh, I'm not liking the 0 delay. No, no fan. Bad. We want some delay in there. Even a 0 turns out was enough to give a good fade. Okay, I think we're going to use literally the number 1, alright? We could have said is man or something. Yeah, I think some of these are going to like have fixed durations, but like some of them will be on times. Okay, the overlapping fade is not as cool as I thought it'd be. 1250. Could be doing math, but we ain't about that life. There we go. Okay, I'm liking it. Still a bit of an overlap there. Yeah, let's increase that again. Let me think this math out, actually. Hold up. Node, so 25 times 9 should only be 225. 1 times 11 should only be 11. Oh, this is what you get for messing with timings, folks. They're not as they should be. Okay, let's try it again. And with this, we'll move on to actually calculating how long. Because it's 9 times cubes, and we have, what, 2,500 cubes? So, or 2,000, rather. So that's 18,000 divides 60. Each one needs to be 0.3 of a second. And that's all on 9, so 0.3 divide 9, each one, that's not 0.3. Each one really needs to be 0.03. We're getting down to frame times at this point. Oh, Lord. Okay, it just needs to be faster, I can tell that. Painful. Very painful. But hey, we're pretty close. We just need this all to go faster. Okay, let's do... At least get the on-screen text up here so we can see our lovely count. Say goodbye there. Oh, we're also going to pre-generate all these and just flip their visibilities on. So let's do that right here. Oh, we shouldn't... It's synchronous. We can use an iffy. Okay, let's basically do all of this. Do-do-do. Do-do-do. Yeah, just render them all. Give them all what we need. Yeah, that rendered true. We're not doing that anymore. Then cube is cube, and you don't have lines. Congratulations. But your visibility, here comes the fun part. So, cube visible, no, Emmett, equals false. So when we do come back, what we do is we say your element cube visible, which is we can hard code like here, is true. That's all we do in our cool, awesome, amazing loop. And if we're cool, then we would check it beforehand, but we're not cool. So we're just going to be baddies. This should eliminate a lot of the initial jittering. You physically cannot tell the difference. Lovely. Okay, now here is my next optimization. So I can see why some of the timing is happening. It's because we are telling this thing to run some weird thing like this, right? So what we need to do is we need to use staging again, because we're baddies writing bad code, to have one trigger the next on these delays. So if init start, so again, we need to name these better, but we ain't getting there. So what we do here is we create a cool, neat function. Functions start processing, which first thing it does is sets the stage to in process, the greatest name ever. And then we do all the fun stuff for let ci equals 0, ci less than q dot length, I guess, ci plus plus. And this is where all the timing magic happens. Async, shove all of this, all of this inside here. Process cube, you will be missed. I guess I'll use throttle function someday, so I'll leave it in here. Right, start processing does that. Okay, and the fun part. Now that we're in here, we can calculate how long it should take and generate these numbers accordingly. Of course, these are minimums, but at the very least, they won't run over each other anymore. Because, okay, so let's grab our delays. So, we need to kind of do a little math here, because this math doesn't need to exist anymore. Say goodbye. Because that was for doing the throttling. We don't do that anymore. So what we need to do is, if we're given 60,000, we'll just do this in the actual code. How many's in the queue? I don't have access because ECMAScript module. Hey, hack symbol. Yeah, we are using, well, we're not really using TypeScript in this exact code. We're just using plain old JavaScript, but yeah, I mean, TypeScript's pretty great. I use it a lot. Hey, thanks for the follow there, Yoda Droid. That's what I'm using to solve all the actual admin of codes in. If you're looking to learn it, then aside from the TypeScript docs, the extension called Total TypeScript is pretty cool. It makes these cool little annotations on new concepts that explains what these things do. So, but aside from that, if you got any questions, I'm not a TypeScript expert, but I can use it. Ah, cool, cool. I mean, yeah, it's not specifically VS Code. Any editor can technically use TypeScript, and it's not really for editors, it's for the code itself. But yeah, I mean, I'm sure all the other ones, IntelliJ, insert Vim here, they all have good TypeScript support. So if I have, wait, how many do I have? Like 2,000, right? 2,067. It's 2,000. So I have 60,000 milliseconds to render 2,000 things, which means each of them gets 30 seconds. Now that's 30 seconds. You have 10 stages of fading and 9 sides. So that's 3 seconds per side. It depends on which ratio I want to give you. So 30, like the fading should be the quickest part, and yeah, because it's the smallest part. So fading, so out of 30, that's 30 milliseconds. Oh lord. Oh no. That's not going to be visible practically. But we'll try this. So divide 10. So 3 of them should be just... Okay, this is going to be a minimum time again, because we're not going to get that accurate without a real game engine. That's alright. So it's 3 milliseconds to do all your fading. Hey, thanks for the follow there, Bolto720. So let's generate our durations. So I guess what do we want to call this? Time per cube equals, yeah, that's right. So 60,000 milliseconds times 2,000 cubes, you get 30 milliseconds a cube. All right, we didn't need to calculate that in here. We can do that out there. So const ms, okay, I could have just said ms per cube. Then it's ms per fade equals ms per cube times 10, because you only get 10 of them. Or you get a tenth time make opacities. There you go. ms per fade. I'm just curious at this point. And this also needs to be... It's my duration up top is 10, and we're not gonna go for such a low time. Oh, you don't like that math, huh? Why? What happened? Oh. Delays is gone. That's okay, we're getting rid of delays. So 29, my math was pretty close. My napkin math. There you go, and then it's 0.2 milliseconds per fade. Yeah, that's what we got. You're gonna do that. It's gonna round up to 1 and be more than 1, but we're here now. Then it's const ms per side equals ms per cube divide 9. Alright, so let me do this math. 30 divide 10. 30 that's not math. 30 divide 9. That's also not how math works. 30 divide 10 times 9. There you go, 27, right? That's ms per side. That's how many milliseconds you got to render every cute little side. Ka-chow, and this is all lows. Let's see if this looks okay on the eyeballs. Big yikes. It's not fading out the other ones. And that's taking more than however many milliseconds that is. I mean, it's not the worst. It's not what we want, though. We're not fading the old targets out. So, oh, we're also incrementing. Don't do that. I mean, you used to do that, but now you're in a loop. A loop does increment for you. ms per fade. So I guess we'll do this based on CI. CI greater than 2, you use that. Otherwise, you use 15 to be nice and human. So CI greater than 2, use the math. Otherwise, you use 100. 500. And yeah, these delays, unfortunately, are too synchronous. They're too small to really be useful, so final solution would be stacking these delays so they don't do this, basically. Like proper scheduling. But I don't know enough about 3GS to know the proper schedule. Okay, you should be going fast now. There's fast. Okay, what if we gotta start eliminating these delays? If because the thing is, they're all minimum of 1 at this point. Okay, yeah, let's just get the text on the screen. DOM and CSS, use Studio Render. Oh, this is it, huh? Just, just use some HTML. Don't get all fancy on us. Okay, I can use some HTML. Da 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 da. Where you put this in the DOM? Where's my DOM? There's nothing up here. Okay, info. Inline styles. But who's gonna stop us? Nobody. Okay, this is great. I guess we want you to have a color of white, and I'll update that thing as we go, I guess. Const set info equals. Oh, not like that. The heck are you doing? Message. Sure, that seems about right. Info, inner text. That technically is gonna work. Oh, I love JavaScript because info is a global created by the DOM because there's a thing with an ID of info. We love that. Okay, guess here, we're not gonna do that in the loop. So if this, else, we're gonna say set info. Just gonna do like a cool percentage, huh? Adding, of cubes. That's a lot of text. But I'm curious. I mean, it's gonna be in 10 seconds, but I'm curious. Ooh, look at that. That's okay, it's very wrong, but I like that. It's all centered and stuff. Okay, so I don't know who told you to math round this. What does should have added, never. No, I don't see the last one. Maybe I should put the round back. Yeah, okay, let's put the round back. Yeah, math, we got you. Yeah, so we will put this in an else. Yeah, that looks good, but what we want to do is we want a toString and we want to pad start for how many digits we actually have, right? So it's render q dot length dot toString. Oh, this is horrible. Dot length. Pad it with zeros. Loving that. And then this is the fun part where we but we don't do that. Processing, where we're also going to set our info to how many empty, whatchamacallits we found. I guess we're going to create a variable for these. Let faces. Finally, we're actually solving the actual problem. Then for every iteration, we're going to be like set info faces. I know how to spell faces. Found. Wow, I know all the words. It's not me, it's my editor. It's dying. Okay, so if we found the cube, then we read it. Otherwise, we didn't find it. Congratulations. A face has been discovered. The fact that, okay, it needs to update as the thingy does the thingy. There we go. Exposed faces. We want to see the number, the new number. Lack of that. There we go. Oh, what was wrong with the other thing? It didn't render the last message. So we want to see the last message. It's technically during a knit. There we go. Let's see how this looks. Look at that. And once this gets to the third cube, she's gonna be zooming. There it goes. Detecting all them exposed faces. Now we're gonna just actually get this on a move on. We're going to not do any delays. Just so we can actually see if we do make progress. Maybe we add a percentage indicator. Yeah, we're adding a percentage indicator. Bop, 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 bop. Again, okay, we'll just do template literals. Template literals are cool. They're hip. So we want math. Oh, Lord. In parentheses, because we got to fix float this. Ooh. Thank you, Copilot. I have to go manually copy that down there because you're not cool enough for multi-cursor. But that seems about right. Thanks, Yoda Droid. Yeah, I figured that'd be, something unique to do. 'Cause last year I did the whole learn a new language or a mess. So I'd be like, this is what. Oh no, browser's about to die. But yeah, I figured it'd be something cool to do. And yeah, this 3GS one's my most complicated one yet. I think my favorite one, although I love the 3GS one, is probably 05. Yeah, it's the crane game, which if you weren't following, it's basically there are a bunch of stacks and you visualize them. Or I visualized them, but this visualizes them as an ASCII crane game. This is my first time using the Blessed library, which allows you to make terminal. It's like, what is that? A terminal user interface manager, or whatever it's called. So this is up until this 3GS one. This is my most proud one, but yeah, eventually. I mean, I was supposed to do it once a day, but time got a hold of me. Yeah, eventually we'll get a visualization for all of them. Probably by end of January or whenever I do get there. Look at that crane go! Again, I also have the same timing issues of where, like, well, I'm waiting like 1 millisecond between operations, so. Yeah. Yeah, I'm liking this 3JS one pretty well. I guess I do want a delay. 1 millisecond. See if this works. Okay, you know what? This is something, to be honest, It's better than nothing. My word, 1 millisecond is still taking more than 60 seconds to get through all of them. Limitations of time. Okay, what it would be cool, so I know the. Dang, 1 millisecond. 0 milliseconds. Go faster. I don't think it's gonna get any faster, but geez, even that's taking a lot of time. It just takes a long time. I don't know what to say. It's a lot of cubes. But yes, like for this one, I can see the final visualization. So like as this is flickering around, again, the first 2 cubes get normally done. Then the next following ones, they will have 9 probe cubes around it, representing the 9 possible things. They'll flash blue or I'm trying to think. Green is good. Well, that's why I like blue though. Yeah, so they'll flash green for exposed air, red for already existing thingamabob, and they'll do that exactly how you're visually seeing here. So no time delay. It's gonna take more than a minute. I mean, I don't know if there's more to say. It's just too many cubes to make it last a minute, or to be meant to a minute. See, that's definitely gonna be part 1 visualization. I do like the rotation though. I guess I can add some controls for like rotating on the other axes. Cause I bet. Watch me do some crazy stuff for you. X, Y, and Z. You'll be. I have to put some motion warnings. I start going this crazy. There we. Oh no. Ooh, it's not exactly centered. Don't rotate on X. Should be able to rotate on 2 of these. Don't rotate on Z. Okay, yeah, this whole boom arm thing is kind of messing my math up, but okay, eventually we'll be able to rotate on the other axes. And for now, this is good enough. But yeah, I mean, this stream has already been a little bit longer than I expected, but yeah, I'm loving this. Let's give it one last full go through at normal time, and then we will find someone cool to raid. So all the people I would have raided me, so we'll see how that works. But yeah, again, I appreciate y'all coming by and everyone for the raids. I mean, it was a raidathon. Starting with Madeline, then Chrissy, then QQ Impact. Again, appreciate y'all's support. And everyone who's still hanging by and watching these cubes fly. Again, any raid suggestions, feel free to drop in the chat. We still got like 2 minutes, I guess, till this thing's done. And this last part of the visualization is kind of boring, but that's how math-based visualizations do work. There we go. You literally can't get any faster than this at this point. I mean, yeah, it's debouncing essentially the delay function, which my brain wouldn't even know what it would look like. Again, any suggestions? I am open. Yeah. Yeah, I'm looking, Stu. I am looking also. I'm like, oh wait, I don't know any of these people, which is cool, but it's like, oh, no advent of code. I guess everyone was like, it's sleep time, not advent time. Day 22. That might be it. I appreciate you looking too, Stu. Oh, that's not good. We're at over 100%. That's great. I don't know what we're doing. What are we doing? Huh. Yeah. Oh, my lord. I'm doing bad math. No, wait. Yeah, I did bad math. We have no idea what percentage we're at. This animation could take years. Okay. Let's see. This wouldn't be too bad as like a break or a starting screen, to be honest. It's kind of hypnotizing. Waiting for my browser to load. Oh, they just went offline. I almost raged yawning offline. Mm. Oh, we made it to the end. Look at that. 3,522, which, if we run keyboard commands, the actual solve code should be this if we got it all right. The longest running, well, it's not the longest song, there are longer. Well, that's not what we're looking for. Great sadness. This is the disadvantage of Quokka. It's very lenient, right? There we go, 3,522. It works! Well, advent of code instead. I mean, that sounds like something. Maybe I didn't scroll enough to find them. If you all speak Italian, I'm more than happy to raid you there. I speak English, though, only, so. Okay, yeah, we can check them out. Thanks for that find there. Advent of code in GNU said day one. Ooh, day one. They've been on 3 hours too. Yeah, we can give them some support. They seem cool. I don't think we're going to get any other suggestions, but hey, thanks for finding them for me, Stu. We'll go ahead and check them out. And yeah, again, appreciate all the raids that came by, and everyone that stayed back for stayed by for the 3JS super professional code that I just threw together. I'll catch y'all next time. Let's raid fellow advent of Coder. Show them some love. And they're on day one too, so with said of all things, which is a crazy thing. I've seen people do stuff with. Might be more up most y'all's alley. See you later, folks. Doodles.